screen. Hello, everybody. Thank you very much for being with us. We had a slight technical issue at the beginning there, but I would like to just hand over to Steve to kick off with the Riverfly Partnership Conference 2023. Thank you.
Great, thanks very much, Laird, and welcome to everybody to our 5th National Riverfly Conference. It's great to see everybody, even if it is virtually. I'm Steve Brooks, I'm co-chair of the Riverfly Partnership. As many of you know, we had to postpone this conference back in 2020 because of COVID. We had planned to hold the conference this year at the Natural History Museum in London. Because of the rail strike, we decided to reconvene it online. Fortunately, because of COVID, most of us are now familiar with Zoom and online meetings, so hopefully that hasn't proved too daunting. In fact, 40 of you bought tickets since we made the meeting online, and only a few have refunded their tickets as a result. So hopefully this will be a success. Well, things have come a long way since Riverfly was launched over 15 years ago, and now we have some valuable long-term data sets. Riverfly has proved itself in identifying many pollution incidents, which the Environment Agency have followed up. And now citizen science has become an integral part of Environment Agency operations, as we'll hear later. Things are very positive for Riverfly at the moment. We have very strong volunteer engagement at a time when the Environment Agency resources are stretched and reports of pollution incidents on rivers are increasing. So Riverfly volunteers are making a great contribution to safeguarding our rivers. Even during COVID, many volunteers continued to monitor their rivers when the Environment Agency were not out on the rivers. And now post-COVID, volunteer activity is picking up again and is set to continue to rise. And we'll hear more in the meeting about how this will be achieved and hopefully to inspire to even greater things. So without further ado, let's start the meeting proper. We're running slightly late, but we might shave a little bit of time off on the lunch. I'm chairing the first session, and the focus of this session is new developments for citizen science on British rivers. If you have any questions for the speakers, please submit them via the Q&A chat, and I will select as many as possible during the question session and put them to the speakers for them to answer. The speakers may then opt to answer other questions via the chat after their talks. I'll warn the speakers when they have 2 minutes left, and the meeting is being recorded. So now to start, I've great pleasure in introducing you to Tamsin Appleton, who's a senior specialist at the Environment Agency. She's based in Exeter in the Water Strategy and Partnerships section, and she manages citizen science projects in the agency. The title of her talk is Embracing Citizen Science in the Environment Agency. So over to you, Tamsin.
Thanks very much, Steve. Morning, everybody. Thanks for having us here today. Steve's already introed me, but my name is Tamsin Appleton. I'm a senior specialist within our Water, Land and Biodiversity section. Also somewhere in the virtual room today is Kelly Haynes, who is project managing our work on citizen science with me. So I'm going to talk to you today a little bit about what we're doing on citizen science. Hopefully that has come up. I'm just going to turn, I've got terrible troubles with bandwidth, so I'm just going to turn my video off whilst I'm talking. So within the Environment Agency, we know we don't have the resources to collect all the possible information there is on the environment, and we can't be in all places all of the time. And we also know that engaging with others about environmental information is often the first step to developing partnerships, making improvements, and we want people to become really engaged with their local environment. Citizen science can really help us here. So I've got some examples of good successes in the organisation with citizen science. So this one is about rain gauge information, which is one of the longest running volunteer-based schemes in the UK, where people collect rainfall information and submit it to the Met Office, and then we use that too. Another really successful one is using citizen science to provide primary source of information in many areas of biodiversity reporting, so used very heavily by Natural England as well with their indicators. And another one where we've managed to get people a bit less about the citizen science data side of things, but a lot more about involvement is our flood warden scheme. So getting people involved in a local level to do with flood protection and resilience. But our successes for water quality are much more localized. So we support some projects and we don't have capacity to support others. Riverfly, as we're here today to talk about, is possibly our most well-known, and most covered across the UK. So we have good intentions towards water quality. At director level for many years, when I started this role, I found papers going back 10 years, 12 years, supporting citizen science, but we've yet to see real consistent progress in how the EA uses or gets involved or helps develop citizen science initiatives in the water environment. So in the last spending review, we secured some funding to help bring that more consistent organisational approach to citizen science. And we've set up a project which myself and Kelly are running until 2025. So the role of the project is to try and learn from prior initiatives and engage further with citizen science to really work out where we can support it and where it can support us. So we're looking at questions like, how do we identify where citizen science can contribute? And then how can we and others use that data in planning interventions? What are the resources we need? How do we integrate citizen science? How do we and others access, store and share data in a way that's compatible? How do we make sure data is known quality? And how do we make sure partners can build their capacity to assess and transform data into evidence for themselves as well? So within our project, we've got the resource to fund roles in our areas with a focus on citizen science. We've got 11 out of the 14 of our Environment Agency areas have now recruited into these roles. Some are full-time roles, some are part of a role, but they're able to bring that dedicated focus on citizen science. And if you want to know who they are, if you want to get in touch with somebody local, email me and we'll put you through to the right person. Those roles are very variable. They're in different teams in areas. They might be in our analysis and reporting, so more of our monitoring team, or they might be in our catchment coordinators, more of an engagement team. So it's area discretion where they see the need for support being the greatest. But they'll be there to help develop, collate and share learning on how the organisation can work with citizen science. So we're very excited about the Catchment Monitoring Co-operative, the CASCO project, and we're hoping to work very closely to move things forward together. So we'll be working closely with them, make sure we learn from each other for the benefit of all. So we're very much at the start of our project, early days, but with lots of possibilities to work through, and we're hoping to solve more answers as we go along. And there's my contact address and Kelly's contact address if you want it, and I'll just turn my camera back on. And that is the end, if there's any questions.
Thanks very much, Tamsin. I don't think there are any questions, but people should, if they have any questions for Tamsin, you can send them on the chat. Can't see anything. Okay, right, brilliant. Thanks very much. So we can move on. I'd like to introduce John Davy-Bowker and Angus Menzies now, who are going to so John Davy-Bowker is a freelance freshwater biologist who was formerly at the Freshwater Biological Association, and Angus Menzies is a river volunteer who works with the Dorset Wildlife Trust, and with Richard Chadd, who unfortunately died about 18 months ago, and Chris Extance at the Environment Agency, and Will Bartle in Lincolnshire developed the extended Riverfly scheme. And John and Angus are going to give a presentation on this scheme. Thanks very much. Over to you.
Thanks very much. Thank you, Steve. I'm just try and get my share screen going. There we go. Okay. Share, you seeing that okay? Yeah. Okay, well, my name is John Davy-Bowker, and I'm going to give you a talk along with Angus here on extended Riverfly. I'll be covering the development, the training, and then I'm going to hand over to Angus, who's going to introduce some case studies. So let's just start with a quick review of the Army 8 group. Well, Army 8 group has been incredibly successful, and as of March 2023, we have about 60 regional hubs across the UK, over 3,000 sampling sites, and 1,000 volunteers. And that 1,000's down quite a bit since COVID, but hopefully it'll recover soon. We've got really good training for monitors, field recording paperwork, the existing online database, which is now being superseded, and a really good scoring system and a trigger level and breach procedure, which works really well. And I think everyone can agree that it's an outstanding example of citizen science done well. So with all the success of the 8 group Army, why did we want to go and make an extended scheme? Well, there were three principal reasons. First, we knew that Riverfly monitors wanted to record more taxa. They were seeing other things in rivers and aware that they just weren't noting any of these things down. Secondly, we knew that Army was really good for acute pollution, but wasn't always completely sensitive for milder forms of stress. Thirdly, there was just really a groundswell of opinion that there was a need for an extended scheme. A lot of people were developing them independently, different places around the country. So a lot of people were thinking along the same lines, and it was kind of ripe for doing, really. So this is a little timeline we've put together just to show how it all got going. We started with an exploratory meeting at Langford Lakes in 2014, Langford Lakes in Wiltshire, where Riverfly and monitoring all got into one room, a very large meeting. And of course, we couldn't actually come up with a definitive scheme in that one meeting. It was impossible, really. But Angus, who sat next to me here, took away the challenge of moving things forward, and very bravely, I must say. And that's when you contacted me, and I started getting involved. And we really kicked things off with a couple of workshops in Dorset, where we put the best scheme that was around then in front of some volunteers, and we took it from there. And that led in 2017 to a draft 28 group system, which we then tested locally and also in South Wales, the Northeast and the Northwest. Then we really started teaming up very closely with the Lincolnshire people, Environment Agency and Will Bartle, and that led to the 33 group scheme we've got today. And then since then, we've been working on a YouTube channel. Quite a bit been going on training, and we've been feeding into the work on Cartographer, the database for Extended. So let's just review what the aims of Extended were. Two, really. First was to provide more detailed data, collect information on more groups. The second was to provide a really important pathway for 8 group monitors to build on their skills and learn more about all of the variety of invertebrates in streams and rivers. Some of the considerations we felt important. We really wanted a scheme that was nationally applicable, not another local scheme. We wanted the sampling method to be the same or very similar to Army, and we didn't want to replace Army, but we wanted a nice clear progression pathway. So as 8 group monitors got really comfortable and skilled with that, they had somewhere to go beyond that. We wanted people to be able to back derive Army data, so you could go backwards essentially. You could revert back without losing continuity and back calculate 8 group results. So the 8 group is essentially nested within the Extended. And we really felt the chart would benefit from lots of photographs rather than line drawings, like in your sort of classic keys for identifying things. So photographs really of things live at the riverbank, just appearing exactly how a Riverfly monitor would see them out in the field. So this is a picture of, I think, our first workshop in Dorset, where we put the Lincolnshire scheme at the time in front of Dorset monitors, and that was fascinating. You really get to see things through other people's eyes in a setting like this, and it blows away a lot of your preconceived ideas about what is going to work and what isn't going to work. And three principal pieces of feedback. First was that it's got to be user-friendly, that people have to be able to recognize these groups at the riverbank with the appropriate training and support. It's no good if they can't tell what the groups are and the data's all just horrible rubbish and wrong. There was a preference expressed for a hard copy chart mirroring our thinking in there, and a really memorable piece of feedback. Somebody said, we didn't appreciate the Latin lesson. So I spent the entire day throwing scientific names at these people, and they wanted common names. So that kind of sunk in. So at that point, we kind of went back to first principles and had a go at deriving a system ourselves from scratch. So we took the RivPax database. This is a database of 2,500 samples from around the UK of high and good quality waters. And across all that data, there's around about 132 families, depending on how you define them. And we tried combining that list of families in various different ways based on the kind of feedback we'd got from the workshop. So, for example, we learned that people couldn't see eyes on flatworms, so we just amalgamated them into a single group. Same with the snails. We just felt they should all be together. There was no benefit in trying to distinguish those. And the leeches, again, the same eyes issue, and the same kind of logic really extended out to all of the groups to make it user-friendly. And this gave rise to our first draft, a 28 group system. So slight aside here, we're talking about 28 groups, 33 groups. I'll just talk about levels of taxonomic resolution when it comes to identifying, well, anything really, but in this case, freshwater invertebrates. The most basic form of ID we really have at the moment is the 8 groups. So you're only required to resolve the presence of 8 groups. Then there's quite a big jump to family level, where you've got somewhere in the territory of 100. You could have 82 BMWP families, or maybe 132 absolute families, depending on how you define them. Then there's a big leap again to mixed taxon, which is the Environment Agency's standard level of identification, which is primarily species, but there are still some big tracts of it which are family level, and these are quite sensibly the hard groups, the Diptera, things like this, the flies. I mean, you might be talking 600 or so species now, including families as well. And then full species ID, which is pushing everything as far as possible with the available keys. And now you're into thousands of species. So this little animation will run, where we sought to place extended was slap bang there, between 8 and the family level, aiming for 20 to 30 groups, bridging that gap. But very importantly, seeking to retain the ability for this to be something that could be done at the riverbank, because family level is often the point at which people switch to lab ID with a microscope. So we wanted it to be sat closer to the 8 than the family. So this kind of depicts the real coming together of the Dorset and the Lincolnshire teams to merge towards a nationally applicable system. This really got going in November 2018, where we kind of got the list of 33 families sorted out. We merged some groups, we split some others. We then went away for another year to get new photographs to support the redefinition of those groups and write some new panels for the chart. And a year later, in November 2019, we had the 33 group chart complete. And here it is. So 33 groups on a double-sided, waterproof, fold-out chart. And the groups are shown from their simplest, that's the flatworms, through to the most complex, that's the true flies. And it's absolutely stuffed full of photographs of macroinvertebrates live at the riverbank, just as you would see them in the field. So, and that's available to buy from the FBA website. So that's the chart. I'll just mention, oh, sorry, no, we're going to just look at one of the panels in a little bit more detail. So here we have photos of distinguishing features for this group, green sedge, a caseless caddisfly group. We've got notes about what those distinguishing features are, what to look for. information on body size. We've got some habitat information, what kind of habitats they live in, what do they eat, space for notes, because quite often Riverfly monitors develop their own little nicknames for things or features that jump out to them. And bottom right, we've got what we call the smileys. They're some little faces that depict the tolerance of this group to 4 principal forms of environmental stress. And then at the fine print in the bottom, if you can just about make it out, it says exactly which family or families in many cases we're talking about. So we wanted to be absolute clarity about what this group comprises. Okay. So here are the groups. The first 6 are all soft-bodied organisms. The next set are the crustaceans. So here, points of interest, we ask people to distinguish native from signal crayfish if they can. That gives some info on the chart to support that. We've also picked out invasive non-native shrimps because we felt that was an important piece of information rather than having those all just as shrimps. And then we've got the mayflies, resolved a little bit in a little bit more detail. It is a Riverfly scheme after all, so we're quite big on the mayflies. Then we have a real mixed set here. We've got all the stoneflies, dragonflies and damselflies, the bugs and beetles and the oliver flies, but many, many distinctive body forms here. So a lot of those panels have got a lot of photographs in because of such variety within those groups. And the caddis, again, we've got some big groups in there, but we've got individual families where they're just very distinctive and easily recognizable. And finally, we've picked out 4 true flies out of the 24 or so you might encounter around the UK in aquatic systems. Again, distinctive flies and things that give information that's environmentally useful information. So that's everything on the chart. So we'll just put a couple of slides on these. So I'm just going to message my internet connection is unstable. I'm just going to press on. Hope everything's okay. The Army 8 group scoring system awards points based on the log abundance category of those 8 groups. So in the brown, in the top right there, you get progressively more points by log abundance category of the 8 groups. But all the 8 groups, they're all treated the same. So you get the number of points from the stonefly, from the shrimps. So when it came to an opportunity to try and make some slightly more stressor specific indices. These are brand new, so we don't know how they perform at the moment, but we've had a go. We've got 2 indices, water quality score and silt and flow score. So let's have a look at water quality score. I will just say that the trigger level setting remains with the Army 8 group because that's a well-established and stable index. So we're not using triggers on extended indices at the moment, at least. So water quality score, by water quality, I mean nutrients, organic pollution, and general degradation. The indices, the taxa in the blue on the right, that are darker blue, you get more and more points up to +4, and these are all organisms that are sensitive to organic pollution. So, and then in the red, these are animals that are tolerant to organic pollution. So, and you go down into negatives. So if we consider for a moment that when you pollute a watercourse with organic pollution, you tend to eradicate a bunch of sensitive organisms. So you lose or reduce the abundance of those blues, the high scoring, and you're left with the tolerant organisms, which were present all along in probably moderate abundances, positively contributing to the score. But when those are the only things left and their numbers have ballooned, then the index starts going, giving negative values. So we're really trying to pull out the 2 ends of the index to discriminate the gradient of water quality. And silt and flow score, exactly the same principles, except here, the blue high scoring animals are sensitive to siltation and low flow stress, and the red organisms are tolerant to those stresses. So exactly the same principles there. Okay, one slide on the database. Dave Gunnell of Cartographer Studios is adding extended Riverfly to the Cartographer database, and we've got a little screenshot of the data entry interface of cartographer here. It's really nice database, very clean, very tidy. I shared with Dave the images from the chart, so direct read across between the chart and the database. And thankfully, the database calculates all the indices for us. So we're not expecting people to try and manually calculate that on the riverbank. The database does it for you. So yeah. Okay, just getting towards the end of my section. Train the trainers. We've just made some big progress really on training. We held 3 one-day courses at the Natural History Museum last year. We invited experienced Riverfly hub coordinators to come for a one-day session to get hands-on training with these 33 groups to identify them. That involved collecting a lot of specimens beforehand. A lot of preparation goes into this kind of thing. I can honestly say that the majority of people didn't really know these groups when they walked in the door, but they all sat a test and almost everybody passed. So yeah, really effective. And we're hoping that that will help the rollout on a local level. I'm hoping we'll be able to do some more of that this year. Last one from me. I've been working on a YouTube channel. It's called Freshwater Invertebrates. Really lucky that name was available on YouTube, but it is. Well, not now, but so there are 90 videos supporting extended Riverfly and I think supporting Riverfly in the other systems as well. And with this, you get to see the animals alive as best we can. The photographs at the riverbank on the chart show you what the animals look like, but there's nothing like seeing things moving. So and they're all ordered and named by group. So you can see, like, in the top, I don't know, the second one across, group 20, other water bugs, and you've got a water scorpion there. So it's all structured in a way that reads into extended Riverfly. Okay, I'm going to pass over to Angus and case studies.
Thank you very much, John. I should like to talk about our experience of rolling out the extended Riverfly project within Dorset. Now, an awful lot of very useful information has already been obtained by experienced Riverfly monitors who've been trained in the extended scheme, and they've worked on rivers across the county, for rivers as diverse as the Asker, the Brit, the Allen, the Piddle, the Jordan, the Moors River. But that's not what I want to focus upon today. I've got 4 case studies I'd just like to share with you. The first is the River Wyn. The River Wyn is a river in South Dorset which flows through the village of Winfrith Newborough. Villagers for several years have been concerned about periodic changes in the appearance of the river and its influence on the associated wildlife. From the very start, we decided not to use the 8-group army scheme because it was felt that there wasn't sufficient diversity of animals within that scheme to engage the monitors for this monitoring long-term in this particular river. The results so far obtained over several years will inform further investigation of untoward inputs further up in the headwaters, particularly farming practices. The River Hook is a river in the west of Dorset. It's a major tributary to the River Frome, which itself has been historically involved in the spawning and maturation of salmonids. Indeed, the River Frome has got international recognition in this respect. However, because of a decline in the number of fish within the Frome, we are now looking further under the management initiative for possible causes of this decline. So 6 sites have been monitored at 2 monthly intervals over the last 2 years along the River Hook. And what the graphs on the right tend to show is that there is consistency between all of the scores that John has discussed, the army scores, and also the water quality and salt and flow scores. And all of them tend to show a tailing off between sites 3 and 4, and with a continued decline by site 5, with a recovery by site 6. Now, we expected a decline at site 5 because that is a highly channelized site. What was unpredictable was the initial decline at sites 3 and 4. So this evidence has enabled us to to look at possible causes for this decline between 3 and 4. The River Cale is a river that flows from Somerset and joins the Dorset Stour. It passes through the market town of Wincanton, where a group of very motivated and diligent individuals wanted to riverfly monitor. Initially, they used the Army scheme, and they were awarded at all 3 sites that they were using were awarded a trigger level of 3. More recently, they have used the developed 33 extended riverfly scheme. A precipitous decline in some of the animals within that scheme at the end of last year was flagged up with the Environment Agency, who rapidly liaised with the monitors to investigate this further. In our opinion, the pooling of these type of results is absolutely crucial to taking further our investigations into river health. So on the map to the left, you can see the 3 riverfly sites. They're in red, the 6 Environment Agency sites, which are in green, and then we also have the 8 groups of Wessex water sites. It's our belief that this case study shows an outstanding example of how the citizen scientist can actually liaise effectively with 2 other organizations to forward the river health. Finally, I should like to just share with you the use of the monitoring project, the extended scheme, to look at changes in invertebrate fauna subsequent to the introduction of 2 beavers in an enclosed site in West Dorset in February 2021. We monitored pre-beaver introduction and have subsequently monitored post-introduction at 2 monthly intervals. Now, whilst a photo may show a 1,000 words, in fact, it's the data accumulation so far is giving us the first real evidence of what is actually happening above and below the dam. And it's showing a trend in the waters above the dams towards the creation of a pond-like fauna, a transition from a river-type fauna. Finally, I should very much, and John would also, like to acknowledge the contribution to all riverfly monitors and volunteers that continue to give their time and passion to riverfly monitoring. And clearly, without this, none of this would have happened. And we also acknowledge the very generous support from the organizations below. Thank you very much.
Thanks very much, John and Angus. That was a fantastic presentation, and we're all looking forward to seeing extended riverfly rolled out and more people using it. We've got time for there's a couple of questions. So one was, will the silt and flow scores feed into the mud spotter interface on Cartographer?
I'm not familiar with that. I'm sorry, I'm not able to answer that question.
Okay, so I know a bit about mud spotter. I can guess who might have put this question. So mud spotter is to do with hydromorphological surveys of the rivers. So and it's a means of for citizen scientists to gauge silt inputs into the rivers, and so that's easy on Cartographer already. So well, yeah, I would imagine we will be able to do that. Okay, so another quick question is there a quality control system anywhere in the extended riverfly to check the volunteers are IDing correctly?
I'm not sure we've got a QA as such, but we do strongly encourage people to come and have refresher training at least once per year. But it's an open question whether QA should be introduced on a more formal basis. And Yeah.
I mean, my experience is that a lot of monitors who are underconfident about their recognition abilities will actually contact me and ask to go on a further course. And we've done that in many cases over the past few years.
I think they're coming together once a year, comparing notes and IDs is quite helpful, because sometimes if people have been recording things wrongly, they can get it sorted out when they meet up. Yeah.
Yeah, I think I'd just add to that we encourage all the Riverfly trainers and extended Riverfly trainers to hold refresher courses, and hub coordinators as well, to hold refresher courses with their volunteers, so they can troubleshoot these sorts of issues. Because I think, as well as identifications, there's also the sampling methods as well that can go a little bit off kilter sometimes. So really recommend people to organise and attend refresher courses.
Yeah.
Another question here from Ed Shaw. Do you have any advice on how groups can win funding to support training and pay for equipment? Slightly, there's a not strictly to do with extended Riverfly, but
it's an extremely difficult question to answer, because essentially I've been on bended knee going around all sorts of individuals and individual organizations to scrounge money off them. So I mean, that's all I can recommend. Just think of some local organization which might have an interest in the rivers locally, and they may be prepared to contribute to your training and follow-up.
I'd just like to add to that, sorry, John, to butt in, but Angus has been very successful at getting local funding. He's been quite modest, I think, because most of the development that we've been able to do on extended has come through funds that Angus has raised from Vitacrest. So many thanks to you, Angus, for doing that. Got another question here from Lauren Baker. Do you have any suggestions on ways to motivate current Army volunteers to take up extended Riverflies?
I'm not sure. I think I think I just let them move over when they feel comfortable. I think people just naturally get to the point where they kind of want to learn more. So just make them aware of it, and
We're about to do a training session on the River Lim at Lyme Regis, and the volunteers, they would like to be trained in the 8 groups originally, but we are going to have us expose them at the end to the 33 group scheme, because we feel actually in time they may well become confident. So there's always that sort of that ability at the end of the tunnel to actually extend their knowledge.
I think, would you say it's true, Angus, that we'd really want people, new people, to maybe get a couple of years of Army under the belt first, 8 group, before they have a go at extended, just to, because going straight in from cold with extended might be a bit too error prone. I think
It can be difficult.
Yeah, thanks. I'd agree with that. I think it is a nice thing to get into, though. I think as you get to know the Riverflies, you'll see loads of other groups apart from the basic 8. And I'd encourage everybody to try and get to know what those, what the names of those different groups are.
Yeah. I mean, the great thing is that people have got somewhere to go now, rather than just jumping straight to family level with peas and line drawings,
Another question from Rainsbourne Riverfly. Along the Rainsbourne in Ravensbourne, I beg your pardon, in southeast London, they've been reluctant to roll out the 33 group because it may be too time consuming. So any comments on the amount of time, extra time, that you might have to spend to do extended Riverfly?
Yeah, it is more time consuming, and this almost circles back to the first question, because if you're very familiar with the 8 groups, it becomes less of an add-on to then take on the 33. And the way that pans out in practice is, when you're doing your 8 group survey, if you're still using the kind of nibbles tray thing to lift individual animals out and put them in separate compartments, but if you're more sort of holding it all in your head and maybe tally counting, if you've got to the point where you're kind of zipping through your 8 group pretty well, you'll probably find it easier to move to the 33. And I agree.
Okay,
Good.
time for one more quick question from Sean Leonard. Sorry. Do you have a mechanism to disaggregate degraded habitat from water quality impacts?
No, I'm not sure I fully understand. Shall we give, is there a chance to just add to that question? I'm not quite sure I fully understand it.
I think, well, my guess is it's to do with habitat versus water quality, as it were. So will extended riverfly separate those two out?
That's quite a big ask. I think that's quite a big ask, even for species level ID, with all of the biotic indices we have at our disposal. Just I'm not sure. I wouldn't want to make any claims on that front, because I know that is quite difficult, even with stuff done at species level. So I mean, we have got two indices. Hopefully they'll respond in a desirable way around their design, but we'll just have to wait and see how they perform as data builds up and case studies build up. Yeah.
Okay, so I think we're going to leave it there. Thanks very much to both John and Angus, and
Thank
particularly,
you.
well, not particularly John, but I know how much time and effort John has put into all the kind of data crunching and developing the system, how it works. So that's a fantastic contribution you've made, John, and it goes beyond extended riverfly as well. We've been talking about other ways we can develop predictive scores, for example, which I think would be a great step forward.
Yeah.
Can I just ask people, so people have been putting messages on the chat, which is great, but if you particularly have questions for the speakers, could you put that into the Q&A so that they're much easier to distinguish, and we can ask the speakers live then to answer those questions. But the chat obviously is useful to put stuff in as well, so people can exchange views during the course of the meeting. Right, so we'll move on now to the next talk, which will be by Nicola Edgar and Jess Andrews, who are catchment coordinators at the Environment Agency in the West Midlands. And between them, over the last few years, they've been developing the Urban Riverfly scheme, which they're going to introduce to us now. Thanks very much. John and Angus, yeah, that's great. So over to you, Jess. Jess, we can't hear you. Is your mic on? No, still can't hear anything.
I'll introduce as well. Jess is trying out her microphone. Can everyone hear me?
Yes, I can hear you.
Great. So yeah, so Nicola is myself and Jess is on the call, so she's just sorting out her microphone for you all to hear her. So yeah, we're based in the West Midlands, and Jess actually currently works now in the biodiversity team, but we've been working together in a number of years on Urban Riverfly and getting it promoted to run the pilot schemes. Jess is doing the PowerPoint, so are you able to just move on to the next screen while you do? Joys of technology. You'd think after a couple of years of COVID, we'd all be better at it, but still sometimes lets us down, doesn't it? I'll see about sharing my screen and just quickly pull mine up. Oh. Jess, are you okay to stop sharing and I'll share mine? Can everyone see that?
Yeah, we can see your screen.
Great. I'm just going to turn my video off so that I can focus on this one. So yeah, we've introduced ourselves. There we go. So we're just going to run through a bit of the background of why we developed the scheme, an overview of the taxa, a couple of case studies for the pilot, and then links how it links with other Riverfly. So like I say, I've worked in the West Midlands for a number of years now, and I've also worked up in the Yorkshire region of the Environment Agency. And over those years, we worked with a number of community groups and things that wanted to do Riverfly, but would often get trained and then become disengaged because of low scores and low trigger levels, or wouldn't even look at Riverfly and wanted to just focus on water quality sampling. And as you can see from the map of where the Riverfly locations are, there's often gaps around those urban hub areas, and particularly a large one across the Midlands. So it was something that we wanted to do, is to provide that link that people could do citizen science and Riverfly and get something from it from themselves, but also to allow that engagement to happen with those long-term trends in data, and that those groups wouldn't just disappear and not be able to keep going because of that lack of sort of feedback or things that they were getting, because they were just seeing sort of gammas and betids, or sometimes not even having anything at all. So yeah, it was to still deliver those goals of Riverfly, of connecting people to those rivers, that engagement, still highlight the severe changes in water quality, get those long-term trends. And for me, as someone who works within the engagement side of things, to get that dialogue between the volunteers and the EA and other partners that we work with on projects. So during that development, we did a couple of pilots linked to different projects that we were doing. We wanted it to be accessible to a lot of people. So not just people that have that sort of biology background or linked to other schemes that they might be delivering. So yeah, we wanted it to be the same method so that people could link between the original ARMI and also do this group, but that it wasn't anything too scary, that the additional groups were easy to identify and you could be trained within one day still. So it wasn't an additional training on top of the original taxa list, it could all just be done within one day. And we trialled it, as I said, largely across the West Midlands, but also then into the East Midlands, where we had access to other EA teams that could help us trial the pilot and just get some feedback from different groups. So yeah, sorry, I'm doing Jess's slides as well as my own, so it's just checking my notes and making sure I'm covering everything. So yeah, the additional 6 taxa, 6 groups, just that those ID ones that are easy to ID, that even sort of school children and generally can pick up quite easy within that day. So as you can see, as John said, it's that grouping of things such as snails and beetles, so that we're not having people go down to species or even family level. You can, those that are more familiar with sort of invertebrate ID, you can see that they're sort of on that scale of more pollution tolerant, so hence why we've called it Urban Riverfly, because it allows those more polluted waters to sort of pick up those changes and subtle changes, and also where we do have those sort of long-term water quality issues, that people can still record something and see those changes that are happening within their water courses. These pictures are from the guide, so as you can see, they're quite nice photo ID, and we've kept the descriptions around the ID quite sort of low level, nothing too detailed, that just really visible of what people can see with those IDs. Similar to the extended, we worked a bit about what groups to include, how to group them, what were common within our urban rivers, to make sure that people could be engaged with this scheme. Like I said, that one of the reasons that we've developed it is because people were disengaged because they weren't finding things. So we've picked things that aren't only pollution sensitive, but are also relatively common across a number of rivers systems. And similar to the extended scheme, we've done a change with how those abundances reflect the scores. So this is linked to the EA methodology about how more pollution sensitive species will decrease as their abundance goes down. As you can see from the snails here, instead of going 1, 2, 3, 4 as it does with ARMI, it will plateau at 1, and then if in particularly high numbers will take the score or level the score off, whereas leeches will bring the score down. So there is subtle changes like that for the scoring system, but cartography, where we store the data, will work those out for you. And all the other scores stayed the same of increasing. So this hopefully will, through the trigger levels and the scoring, pull out those differences in those urban waters that's going on.
Is everyone able to hear me now?
Yes, Jess. Is there anything you'd like to add from what I've already said?
No, it's all right. I just thought I could say I can pick up my slides now.
Okay, great. So yeah, so this is the guide's been redeveloped with help from ZSL for the funding of it and some pictures from John. So we do have a new guide that's out for trainers and volunteers, including those pictures. And it's like we've said previously, it's about things that are visible for people to ID really quickly. So that's the front of the guide, and then the back is very similar to the previous guide, but now also includes more detailed on the scoring system and things like that. This is Jess.
Yeah, so this is just a case study that we've done in our area. So the Lion Brook was formed as part of a community group to establish and monitor the water quality enhancements. So it was on the back of some habitat enhancements that we'd done in the area, and then we managed to get some funding for a community group to kind of do some post-habitat monitoring and looking at long-term trends in data. And they were originally just getting like quite low scoring army and almost just seeing changes in baitids, but after doing kind of the Urban Riverfly scheme, they were able to kind of be a bit more engaged and having discussions about additional taxa and seeing a range of other species as well. So the group have been actively monitoring since 2019. So we've got some long-term data from them as well. And they're looking to increase the number of sites to investigate water quality concerns as well. So yeah, thank you.
One of our other successful citizen science with the Urban Riverfly is the Sherborne Valley project, which runs through Coventry, which is a very urbanised area of the country. And we wanted to look at catchment scale delivery of citizen science, particularly the Riverfly, and how that can be used to collect the data around that project delivery of river restoration and engagement in improved water quality, but also in that how it can be used to engage people and reconnect them with the river. So like I said, it's catchment scale delivery of citizen science. And so far, as you can see, we've got some real enthusiastic volunteers. We didn't do the traditional Riverfly there because the scheme we were already developing the Urban Riverfly. But when we've compared the scores, they would have had quite low traditional Riverfly. And it's felt that they do get a lot more out of having a few more groups to identify. And as John said with the extended one, I think people take some real pleasure in expanding their knowledge on these things. So at the moment we are using it as that pre-data before we go in and do some restoration. So hopefully we can do some analysis of how that shows changes over time with the restoration work that's going on. And like I say, we're working with the project team there. They're really enthusiastic with how this is working to engage the communities. I mean, we're all on this call today because we like getting in rivers and we like doing that. So yeah, and I think that this would have been a previously non-engaged community with knowing what's in their river. There's always a surprise at what they can find there. So we're hoping to expand the sites and other citizen science things that they can do within this project. Yeah, so this slide just kind of shows like the different, obviously the
different Riverfly schemes out there. I mean, you've already heard about the multiple benefits of extended Riverfly, and it's just to say that it's not kind of one or the other. It can kind of, one can lead to the other, and yeah, so kind of comparing the two different schemes, if you're thinking which kind of is more appropriate, it's kind of generally more considered if you've got lower army trigger levels. You kind of want some of the pollution tolerant species, then the kind of urban might be more relevant. You will get the pollution tolerant species in the extended, but you kind of will have other kind of sensitive species that you wouldn't see in an urban river anyway. So, and then you kind of more suitable to urban or lowland rivers. And again, with the urban Riverfly, previous Riverfly training is not necessarily required beforehand, because it's kind of only a few additional groups. It kind of, you could go straight into that if you wanted to, or you can progress to that. Whereas with extended, you probably need to do a bit more Riverfly training before taking on those additional groups. But both schemes are good in terms of if volunteers want to extend their knowledge on invertebrate groups, and just kind of want to increase their data and expand their interpretation of the rivers, then yeah, the benefits of both schemes as well.
Yes, I just wanted to link it in with the other Riverfly Plus schemes that are out there as well, because from the case studies that we've done, particularly the Sherborne, we found that linking it in with Morph, which is looking at your habitat, and your outfall safari, and sort of your water quality via Freshwater Watch, really helps build up those pictures and that engagement. And you might have some volunteers that like doing a mixture of the different citizen sciences, and some that will only just want to do the Riverfly or the outfall safari. So it's a really good way of grouping things together and building that knowledge of what's happening along your catchment. I think one of the questions previously was about, can you separate out water quality and habitat issues from just extended or, you know, species ID? And yeah, that it is difficult, but that's where building up that picture with other citizen science can really help build that up, to have that conversation with other partners and the Environment Agency, but also build up that knowledge and that within the community about what is impacting on their river. And I think that's a useful conversation to have with everyone.
Yeah, so this was just a little bit about certification and training. So we have developed an Urban Riverfly pack, which is essentially the same as a normal standard army pack, but it will just have the different species guide in there. And then also in terms of certification, if you're kind of going from fresh, then you'd have the normal army certificate. And then we've developed a sticker. You can see the little shrimp in the bottom. So that kind of would become as a sticker that you can add to your certificate. So if you're already army trained, then you'd get the sticker to kind of add to your certificate. Or if you're kind of going straight from fresh, then you'd get the certificate and the sticker as well. And then just in terms of training, we're planning to do a soft rollout similar to the extended Riverfly, in that it will be existing Riverfly tutors, and then kind of it'll progress from there. Also just kind of a point of, if anyone's extended Riverfly trained, then they'll have the knowledge in order to be able to do Urban Riverfly already, because a lot of the similar groups like leeches, black fly larvae and snails are already covered in extended Riverfly anyway.
That's us up to questions.
Okay, thanks very much. I've got my video back on. That was great. Thanks, Jess and Nicola. A very nice presentation. I just mention that we've already trained around about 25 extended Riverfly tutors. So if anybody wants to be trained in extended Riverfly, they can get in touch. Well, they may already know who their extended Riverfly tutors are. If they don't, then they should get in touch with Trini, and she'll put you in touch with the trainers. in terms of the urban riverfly, as Jess and Nicola said, if you're already trained in the basic army, we feel you could just move on directly to that. But we do have an urban riverfly training PowerPoint presentation available. So if you want to train new volunteers in urban riverfly, you again get in touch with Trini and she'll send you the training presentation. And we've already got one urban riverfly trainer who's specifically trained, that's Josh Hammond at Thames 21, who's been specifically trained in urban riverfly. Right, so we've got time for a few questions. Sorry.
I've noticed one in the chat.
Yeah, go ahead.
So it says, our urban riverfly taxa from the EA and additional to the 33 groups and extended or 8 group army. So essentially it's got the 8 group army within it, and then it's got an additional 6. So Simulid, which is blackfly larvae, is already in the 33 group. Snails are as well, and worms and leeches. They are all covered under the extended. The only difference is that we've grouped the beetles together, and I'm pretty sure the extended kind of separates them out a little bit further. So I think that's essentially the only difference. So that's why we said basically if you're extended riverfly trained, then you'd be able to do urban riverfly as well.
Excellent. The question from Charlotte Hawkins, which is, will there be trigger levels set for urban riverfly? And at the moment, we don't intend to do that. The same goes for extended riverfly as well. So trigger levels will be based on the basic army. So there won't be trigger levels reset. There's a question about shifting baselines, which I think is an interesting point. Because I think that, I mean, one thing I'm aware of is that we're monitoring rivers that are already impacted, and we're looking to see if they're getting worse. And I think it would be quite nice to see if we can get them better. So Jess or Nicola, have you got any views on that?
Yeah, I mean, that's why we developed it, and particularly around where we were delivering projects, because it was to see if we were making those improvements. So ideally, that is what we're going to be picking up on these things, but also part of the reason that many of the groups were disengaged in our urban areas was that, you know, their base levels were quite low, but that doesn't mean that you can't then still have a pollution on top of that. So it was to both pick up where we were having those infrequent pollutions in an area that was already quite degraded, but then all to work out how we can pick them up. And that's where it works really well with something like the outfall safari, so that you can pick up those long-term trends of sort of averagely poor water quality, but that then if you still have a pollution episode, you can pick it up. And I think people are more willing when we've done this to report those in, whereas rather previously they thought, oh, it's always polluted. Well, that isn't always the case.
I think it's important to say as well, like, although they'd be doing the traditional army, they might not just be getting just baitids and shrimps, but because you're still maintaining their knowledge of army, hopefully, although they're going to be seeing the pollution tolerant, like you say, when it starts to improve, they start to get those traditional army groups coming in as well, hopefully.
Dennis Willis has asked where you draw the boundary between urban and rural. I think you've sort of addressed that in your talk, but do you want to add something about that?
Yeah, so we've called it urban because that was where we were particularly wanting to target those community groups that weren't delivering citizen science, but it can be used anywhere really if you just wanted to expand that knowledge. And it just, like the extended, it's just a way of increasing that knowledge of what's there. Slightly changes the scores to reflect what things are happening. You might find that if you're in a rural area, you can do the urban riverfly one, expand your knowledge, and then as people become more interested, move on to extended. It might be for some of those groups a stepping stone between them. So you can use it anywhere, but I don't want it to replace the original scheme. It was about engaging people who were previously unengaged.
Yeah. Brilliant. Bob Thornton's asked, is monthly sampling twice as useful as bi-monthly sampling?
Oh, there's always a debate. When I speak to my community groups and stuff, we usually have a little bit of a break over winter because no one likes to be frozen on a riverbank. I think it's really what your volunteers are wanting to do. Monthly is always really useful because we can pick up issues in summer with like low flows and things like that. But I wouldn't want to send people out more than they're willing to do, because that will then also make them not want to go out. So I really think you should be volunteer led about what they want to do. Even if people are only going 2 or 3 times a year, it's still really valuable information.
Okay, that's really helpful.
We've got another one of how did you come up with the scores for the extra taxa? So this was based on the WHPT whipped methodology used by the Environment Agency. In that kind of the extra taxa, when you get more of the pollution tolerant species, it kind of goes down in the score, similar to the extended Riverfly.
Okay, well, I can't see any more questions, so I think we'll move on now. So thanks very much both to Nicola and Jess, who I should say, as far as I know anyway, have developed this in their spare time rather than while they were being paid by the agency. So that's a fantastic contribution that you've made. So many thanks for that. So we'll move on to our next speaker, who is Louise Lavictoire, who's Director of Science at the Freshwater Biological Association and also co-chair of the Riverfly Partnership. And she's going to be talking to us about new developments and future plans for the Riverfly Partnership. So I'll hand over to you, Louise.
Hey, everybody. Thanks for that intro, Steve. Hopefully you can see my slides there.
Yeah, we can see and hear you.
Great, excellent. Hi, everyone. Hopefully, yeah, you can see now. Yeah, brilliant. Hi, everyone. Thanks for that intro, Steve. So I'm just going to talk to you today about what has happened over the last 12 to 18 months with Riverfly. So for those of you that don't know, the FBA hosts the Riverfly Partnership, and you'll all know Trina Bregstein, who unfortunately can't be with us today, but she is the Riverfly coordinator for the partnership. So a lot of this information that I've gathered here is thanks to her. So just heads up to Trini there. So let's start with some current stats. So I think it was John who mentioned there was a kind of a slight drop off after COVID. So you can see some of the records that have been uploaded and trigger level breaches between 2019 and 2022 there. So you can see, yep, during the COVID years, we did have a drop off, obviously, as people were entering lockdowns, and that has started to recover quite nicely now. Still a little ways to go, but it's definitely on the upward tick. And the number of trigger level breaches is around about 5%. It kind of oscillates around 5% every year. So that's staying fairly stable with some fluctuations in there. But the number of hubs that we're up to is about 60 hubs with over 3,000 active sites currently, and over 1,000 active monitors, which is all fantastic. And it's great to see so many of you on the call today and at this conference. So just to give a really quick overview as to the main kind of activities that have been happening over the past 12 to 18 months. So as has already been mentioned, we held our first kind of extended Riverfly course last year, and hoping to hold some more this year as well. I'm going to go through some more information on the development of Cartographer, which is the new where the new kind of database will be, which will replace the old database. So there's been lots of developments with Cartographer over the last 6 months as well, in particular. We have the extended ID guide for Riverfly has been reprinted because that was so popular. So that just proves what a great resource that is for monitors and volunteers. And that, as John mentioned, is available on the FBA website. And we're also kind of expanding our activities and promoting ARMI within the Casco project, which Michelle Walker is going to be talking a bit more about. So I'm not going to go too much into that. I don't want to steal Michelle's thunder for later, but we've been working with the Casco cooperative over the last 12 months or so as well. So just to give a bit of an update about the Esme Fairbairn Foundation grant, which I'm sure all of you know about by now. So just before Christmas, it was a lovely Christmas present to find out that we had secured just over £300,000 for Riverfly over the next 3 years to do a range of things. But this was really, we put in a bid to Esme Fairbairn to address some of the capacity issues that we have. So as I mentioned, Trini is our coordinator nationally within England. But what we were finding was that obviously this method is such a fantastic method that those within Wales and Scotland were using it, but we don't have capacity currently to push Riverfly as much as we would like to within other countries, because up until just before Christmas, our sole kind of funding source was from the Environment Agency, which obviously only operates within England. And so we had the capacity to really only support Army within England, and we knew that Urban and Extended were really popular methods that and people were clamoring for them to be pushed out as well. But due to resource issues, we basically had to support where we could, but we really wanted to support those additional schemes, as well as kind of push out and support those trying to do Army and kind of extended methods within Wales and Scotland as well. So basically the money that we've got from the EFF will help us do just that. So more of Army, but also so kind of pushing out the support into Wales and Scotland. And I know that we've got our Scottish colleagues talking a bit later on about the great work that's been going on in the Lothian-esque, as well as some of the other additional methods as well. So that will be great to hear. We also wanted to engage a wider group of people in all Army methods, in all Riverfly methods as well. And this money will really help us kind of target those pockets where Army currently doesn't operate and where Riverfly isn't as common as we'd like. So that'll give us some capacity to do that as well. And it will also help to fully support the roll out of Extended and Urban Riverfly in all areas as well. We're doing this in a kind of a controlled way. So we're not trying to do everything everywhere all at once, which is a great film. But we're not trying to do everything all at once. We're going to start with rolling out the different methods into Scotland, more into Scotland and more into Wales. We in fact have had some great contacts within Wales already come to us and say we want to set up hubs, and so we're now able to help support that happen in a much kind of faster and more coordinated way than we would have done 6 months ago, which is absolutely brilliant. We also one of the major things that the Esme Fairbairn Foundation funding helps us to do as well is think about the long-term financial resilience and sustainability of Riverfly. So as I mentioned, up until now, our funding and our kind of capacity to deliver what our Riverfly monitors need us to deliver has been limited to what we can support through that funding that we had from the Environment Agency. So we're thrilled that we've got this funding for the next 3 years, but what is beyond that? This will help us to really kind of think about where the financial future of Riverfly lies and how we can make sure that is resilient going forward so that Riverfly can continue to grow. So I just wanted to highlight that you may have seen that we've got 2 new roles being advertised currently. So applications close on the 24th of March. So in addition to Trini as our Riverfly coordinator, we will have an additional coordinator role and also a UK development manager. And that development manager will be kind of focused on ensuring that the coordination within the different countries is the same, and identifying areas for that sustainable finance going forward as well. So if anybody wants to apply or know somebody who would be great for those 2 roles, you've got about a week to get those applications in. So please share far and wide. So one of some of the early things that we're looking to do, and some of this has been mentioned already actually, so it's really nice to hear that that there's a want and a need for people doing refresher training. So one of the things that we really want to do is to make sure that all of the training materials that trainers use to train monitors are standardized, updated, We also want to we want to make sure that the engagement that we have with hubs and Riverfly monitors is a lot better. We've been doing the best we can, but this additional capacity that we're going to have with extra bodies and extra coordination time is really going to help engage with the monitors. And I've already seen a couple of comments saying that people feel they're not supported as well as they could be, or that they're kind of isolated and they don't feel like they've got the support they need to know that the data that they're collecting is making a difference, and that's something that we desperately want to address. So we're going to be keep an eye on your emails. We're going to be coming to you for we're going to be putting out some questionnaires for feedback, and floating some ideas. Would Q&A sessions, question and answer sessions online once a month or once every couple of months be useful? What would people like to see in terms of online resources? So if you need refresher training, would you like that delivered kind of in person or online, or hybrid? So all of these things are kind of in the mix, and it's going to be a really exciting time for Riverfly over the next 12 months. So do keep in touch with us, and keep an eye on your emails, because we will be coming to you for feedback and ideas about how we really kind of progress going forward. So just a very quick update on Cartographer, and I'm going to play a short video that Dave Gunnell has made for us, which is brilliant. So Dave Gunnell at Cartographer is building the new database and mapping system for moving the old database into Cartographer, so that everything is in one place and is a lot more user-friendly. So development of that has been going on in the background, and we're looking at migration of hubs to start in April. And this will be a stepwise thing. This isn't going to be all of a sudden you stop using the old database and you start using the new one. It's very much going to be a controlled and an incremental process. So again, do keep your eyes on your emails, and a lot of information will be coming through from Trini and Dave when the time is right to start moving people across, and also providing training in Cartographer, because it is different to the old database. So we will start moving hubs across who are already using Cartographer. So any bugs that are identified can be sorted out before we kind of move over the bulk of the hubs. The data migration tool will come online to move data across from the old database to the new database, and that's likely to be something that's done kind of towards the end of the development process. But rest assured, any data that you are putting into the old database will be moved across. And if anybody accidentally uses the old database before we switch it off, the migration tool will be run several times to make sure that no data is lost during that kind of crossover period where we're moving across to Cartographer. Yeah, so I'm going to try and play this video, and if this doesn't work out the way I think it's going to work out, do shout up and let me know. So I'm just going to click on this link, and hopefully the share screen will move across. If not, I don't think it is, to be fair. I think I'm going to stop sharing.
All okay, Louise.
Oh, it's all okay. Excellent. Seamless led. Right.
Hi everyone. This is a quick video to show you where we've gotten to putting Riverfly onto Cartographer. The good news is we're nearly there. We're essentially feature complete, barring a few bugs, and we're looking to start rolling this out to existing users of Cartographer towards.
We've lost the. I can't hear anything now. I don't know if anybody can hear me.
Louise, you might need to stay unmuted for us to hear the sound.
Which are.
Apologies. Okay, I will take it back a few seconds.
Groups from the beginning of April, possibly mid-April. So just to show you what we've been working on, we've built a brand new Cartographer website, which has two really important new features. The first one is called projects, which are essentially different streams of data recording. So we have 4 projects for the Riverfly program, a Riverfly project, Urban and Extended Riverfly as well, and then a 4th one, which we're calling Riverfly Sites, which is where we're recording monitoring locations. So each of these is a set of data, a set of survey forms, and a set of people. So surveyors to record data, approvers to QA it, and coordinators who can add more people to the projects. They are managed separately, but we can appoint administrators to manage multiple projects in one go, and that's how we're kind of dividing access amongst different people with different concerns. The second big feature is teams. So here you can see a list of the teams that we have currently for Riverfly and Cartographer. These, broadly speaking, correspond to hubs and groups. So you can group people together into a team. You can assign that team to one or more projects, so it can record different kinds of data, and then it can do its own QA, and coordinators can invite new people to the team independently of sort of central control. We have new survey forms as well. So we've started to look at splitting Riverfly sites up between teams. So here you can see green ones, which belong to Thames 21, and blue ones, which belong to Surrey Wildlife Trust, I believe. And when you select sites on this form, this is the wrong color, that's a bug, we can tell you which team they belong to and so on. And we started to improve our forms with things like the ability to skip sampling if the conditions didn't allow it, such as there was a drought or the river was frozen. And if you get a trigger level breach, you can also, there's also a workflow in there to do a second sample to confirm the breach and then to report the breach to the EA if necessary. Finally, looking at the maps, we have maps for each of the three kinds of Riverfly, and we are aggregating data from each of the sort of surveys or the projects that is more advanced, if you like. So the main Riverfly map has data from standard, urban, and extended Riverfly. You can dip into any of these data sets, and you can color code it to show what teams recorded what. You can even see the color scheme here and the distribution. You can show things like where there were trigger level breaches, in fact, what the trigger level is, and so on. And you can get different legends for each of those things. So we're still tweaking the maps a bit to make them more user-friendly, but we're essentially there in that we can gather data and we can present it back to people. So that's a quick overview. New website, projects and teams to help model the different kinds of Riverfly and the different hubs and groups, new survey forms, and new maps. And if anyone has any questions, do get in touch. My email address is dave@cartographer.io. Thanks for watching.
I'll go back to the presentation now. Let me know if you can still see the presentation or whether you're still on the browser.
Yes, we can see the presentation.
Excellent. So my last slide is really just a plea for anybody who is out there doing your great monitoring work and wants to contribute your stories to the newsletter. I know Trini would love to hear from you, so her email address is there. The next newsletter is due fairly soon, so we want to hear from you. We'd be delighted to hear from you, so do get in touch, and I will leave it there.
Okay, thanks very much, Louise. That was a great update. It's great to see things moving forward. Well, I mean, the grant funding we've got from SE Fairburn is a fantastic opportunity, that something we've been needed for a long time. There are a couple of questions here. So one question from Ian Banks is, are there any plans to extend Army into the national curriculum?
That would be awesome, wouldn't it? That would be really great. I know that there are natural history, you can now do GCSE in natural history, I'm pretty sure, but I don't think Army it's not something that we're looking at, but certainly it's something that we could consider. In terms of, I'm just not sure, I'm kind of pausing because I'm not sure on the health and safety implications of national curriculum and Riverfly monitoring for those under 16, but it's a nice thought. So when we do come to sending out those questionnaires and seeking feedback, definitely include that, because we have been asked it before, and maybe it's something that I think might be something that the Casco projects helps us to tease out as well, in terms of inclusivity and ensuring that we're engaging people at a young age, so they start to care about this stuff before they're kind of too old and and you lose them when they're teenagers a bit, don't you? So yeah, it's a really good idea.
Another question from Claire Higson is, will cartographer training be available to everybody or just to hub coordinators?
So at the moment, included in the contract that we have with cartographer, it will be available to hub coordinators, but will include some how-to videos and also a certain amount of kind of feedback from monitors to hubs to say, oh, we're not sure about this, we're having problems with this particular function. That will be fed back to cartographer as well. So there will be opportunities for training, and one of the things that we are going to make sure that we do is there'll be short. Loom is a great website actually for doing short presentation style videos to show people exactly what to do to fill out survey forms and submit data as well. So there will be online resources to help with that. In terms of formalized training, we see it working as kind of training the hub coordinators, and then that will trickle down to monitors from there.
Okay, thanks. And just one time for a quick question here from Bill Brierley. So what visualization of data will there be from sites in cartographer?
Yeah, you got a little bit of a preview there on the kinds of things that you can do. So in terms of data visualization, the data will remain open access, and if you've used cartographer before, you know that you can kind of delve into the data in whatever way. So Dave, for example, showed there that you can look at different group levels and see where the data are coming from in terms of groups. You can also kind of break it down into the extended, the urban and the army schemes as well. I'm sure we can do some pretty nifty things with some potential kind of map storyboards as well, but that will be something that yeah, we can look at a later date. But in terms of all of the data being on cartographer, the maps and the functionality within cartographer is pretty good.
Great. Okay, thanks, Louise. I mean, we can address some of these. There were a few more questions on Q&A, so we can address those typing in answers. Everybody can see the answers as far as I understand it as well. Okay, so great. So let's move on to the next speaker, who's Joe Pecorelli. And Joe is project manager at the Zoological Society of London. And he has developed, launched and coordinates the outfall safari method. And he's going to talk to us about that under the title of Why Outfalls Matter in Urban Rivers. Get ready to go on safari. So over to you, Joe.
Thank you very much, Steve. There you go. So can you see my slides, and can you see me? Because I can't see my camera.
Yes, we can see you.
Oh, good.
That's
great.
A fantastic asset. And we can hear you and see your slides.
Lovely. Thank you very much. Yeah, well, I wish I was going to be talking about some beautiful creatures, showing you beautiful pictures of lovely creatures like John did earlier, but I'm afraid it's the pre-lunch slot, so we're going to go sewage with me, which seems a bit unfair from the organisers to do that. But thank you very much for including me in this conference. I'm really pleased to be here. Yeah, so we're going to be talking about outfalls, the need to be monitoring outfalls, and I'm really pleased that Jess and Nicola earlier already made the link between the Urban Riverfly scheme. So if your river's scoring below 5, essentially, then I'd hope you'd be interested in systematically surveying outfalls. Our interest started in 2014-15 or so, specifically through a partnership project that we put together, or we're part of rather, on the River Crane in West London called Citizen Crane. And we recognised that we really needed to get to grips with how our outfalls, what the impact was of our outfalls. And we thought the problem was mainly around misconnections. And in fact, there's a really interesting paper that came out at that time, the one on the screen there by Ellis and Butler, that talked about between 1% and 5% of properties in London are misconnected. So a serious issue. And just to be really clear about where we're talking about now, or where this method is relevant, or where you need to be monitoring outfalls, it's in areas of separate drainage systems. So rainwater going off through a surface water drainage system to the river, and foul waste going to the sewage treatment works. So that's where you really need to be thinking about this issue. Just to go back to that paper, 2015, Ellis and Butler, they also said there was a clear need to develop a systematic procedure and appropriate protocols for identifying polluted surface water outfalls. So that's what we did. We developed the outfall safari, and I'm really pleased that it's being used in various places across the UK now. But just a bit of background and a bit of context. Yeah, sorry, we're going to go grim for a few moments, but in 2015, we thought it was all about misconnections. So obviously, this is sort of domestic plumbing, often washing machines and things plumbed into the surface water drainage network, and they're clearly part of the problem, but they're not the whole problem. There's a variety of issues that we will pick up through these surveys. So blockages, which cause the foul to back up and find its way into your river. Surface water drain abuse, which I guess is sort of like misconnections, but people just pouring stuff down the surface water drainage network that ends up, or surface water drains that ends up in rivers. Those things manifest themselves in dry weather, and we will see those by using the outfall safari type method. There's also issues that manifest themselves in wet weather. So what things that are euphemistically called network issues. So these are generally cross connections. So these are poorly designed assets. The image there is of a dual manhole where the differential between the surface and the foul is too small, and there's a missing cap. So the foul and the surface will mix even with just a bit of rain in that system. And obviously a lot of rain can cause systems to back up and flow out onto the streets. And that's a lack of, that's undercapacity in our system, and a lack of long-term planning and investment. So other issues at stake, other issues to look out for, they all cause these sorts of problems in our urban rivers. So thinking about the impact of rain. So this chart, what you're looking at, the blue lines is rain events, and then the different coloured lines are ammonium readings, concentrations taken using sondes. So that's a bit of kit that they have sensors on, and they send data in real time up to a web-based platform. And you can see when it rains, we get these spikes in ammonium, and that's the first flush. So if you get a long period of dry and then rain, you get a bigger spike of ammonium. But subsequent rain events also cause ammonium to spike. And that's generally those links, those cross connections, the links between the foul and the surface. That's all adding organic material into your river that you really don't want. And in dry weather, this is how this is really getting to the nub of the problem, because it's concentration that kills, of course. And in wet weather, those concentrations are generally diluted. But dry weather, what happens is over time, the orange line here, again, this is data gathered using sondes. The orange line shows the ammonium coming up as the dilution factor reduces. So the amount of water in your river, your urban river, reduces. The concentration, the background flow through misconnections, blockages, whatever, increases. And that has an impact on your oxygen levels, because all that organic material is supporting the bacterial community, which draw out the oxygen. So the blue line, the diurnal pattern there, the blue line, the oxygen dropping. And it's this impact really that means that your rivers are going to score less than 5. This is a primary influence, or if other things are all in check, good habitats and such, it's the water quality, and it's this scenario that's going to sort of side out the more sensitive creatures. And over time, some of our rivers, these are the trends we're seeing. This is 20 years of Environment Agency data, again in the Crane. shocking trend of increasing ammonia levels within the upper sections of that catchment in particular. But I'm sure, you know, the crane is not unique in this, and this is really about lack of keeping our eyes on the problem, lack of investment, lack of long-term planning into our foul drainage system. So it needs addressing, and it's big issues there. Right, so let's get back to the outfall safari. It's really a very straightforward and simple method. If I was in the room with you now, I'd be asking for a show of hands to see who's been involved in an outfall survey in your area. Basically, it's a display of oh, there's a few thumbs now which are distracting me. Thank you. I'm glad you've been involved in these, but we run the outfall safaris in dry weather. That's key. We train our volunteers. We give them an app, or we don't give them an app. We use Pecorelli, and they download the app that we create, the forms we create, onto their phone, and then we coordinate the survey over a 1-month period. Generally, what happens is that after the training, when we require dry, it starts to rain, and it's exactly what's happened this year. We train, it rains, but we really, I must emphasize, we need that dry weather for volunteers to go out and assess outfalls, because the evidence of pollution gets washed away in rain, because of course it's building up in the surface water drainage network, and that's exactly what that network is designed to do, to convey rainwater from the land to the river. So a bit more detail here for the volunteers. There's 2 sections to the survey. There's the volunteer section, and that's just on the bankside surveys, and as I said, they're trained, and a very important part of that is the safety element. So hogweed, for instance, is a particular problem that we have to flag up, make sure they're aware of not touching hogweed. Generally, we run the surveys through March to July, because that's when the weather's a bit warmer, so you get faster manifestation of sewage fungus, which is one of the key signs of pollution. And by July, then the riparian plant growth starts to obscure outfalls, so it becomes a bit harder to see them. So that's the really good period to run these outfall safaris. And as I say, we coordinate the volunteers over a web-based platform. We've used several. At the moment, we're using a thing called Padlet, which does the job, and it allows that 2-way communication between a group of people. And that's essentially for mapping progress. So the surveyors tell us where they've been out. They can organize their surveys across the platform. So and they tell us where they start, we map progress. We identify areas of private land where they've not been able to go, so we can follow those up later with the in-channel surveys. Very importantly, we feed back on the data, because of course we're seeing the data coming in, and we feed back on their assessments. There's generally a tendency to overscore outfalls, and I'll get to the outfall scoring system shortly, but and it's really important that we make sure the data is robust, and we're not wasting anybody's time with the follow-up on these pollution problems. So yeah, coordinated over over Padlet, and then after the volunteers have been out, generally partner organisation staff get stuck into the hideously stinky ditches out of sight, often behind locked gates. You know, local authorities have the keys generally, or Environment Agency, and invariably we see the worst problems in these out of sight areas. I'll come back to some of those. So about the assessment, well, when we developed this back in 2015, we developed it with staff from the Environment Agency and the local water company, which for us is Thames Water. And essentially they had already produced this good practice guidance for polluted surface water outfalls through an organisation called Water UK. And they had some initial sort of questions within that document to trigger further investigation. So we basically took those questions and put them into the app. It's really straightforward. There's about 8 questions 3 of them concerning the condition of the outfall, and the rest generally are around the location, so you can have follow-up action and you can find the outfall once it's been reported. To stress again, 48 hours of no rain, and that's when these problems manifest themselves. The problems, the signs we're looking for are sewage fungus, that's the big giveaway, so the grey, discoloured water, and what's euphemistically called rag. Apologies again, pre-lunch slot. And then there's just 2 scores within that, 2 questions within that system that we convert into an impact score that allows the prioritization. So I'm really pleased to say that now in London, with the help of all these wonderful partners, we survey every river. So there's about 500-600 kilometers of surface water running through Greater London, and we survey all of that over a 4-year cycle, a 4-year rotation. So every river gets repeated each 4 years. Put that another way. And this year also we're spreading the work out into the Thames Valley. So if you live Oxford, Swindon, Wantage, there's a few others, please get in touch with us because we're looking for volunteers to support with those. In London, we get an amazing number of volunteers. It's incredible. Since 2016, we missed a year for COVID, 341 people coming out to spot sewage fungus. That's amazing and fantastic. You can see we've surveyed 500 kilometers or so. We've assessed nearly 3,000 outfalls, of which 322 are scoring over 6. And like I say, I'll come back to the scores shortly. Over 10 is an acute problem, and they get reported directly from the river. So this is what it looks like. So if you've got an impact zone of greater than 30 meters, then that scores 10. And if that impact zone smells really bad and has, I said it was a very basic system, it has a large covering of sewage fungus, then you're going to score about, you're certainly going to score over 10. And it's a sign generally of a blockage in the system causing foul to discharge into the river. And 97 of those over the period that we've been doing this. So it's really worthwhile, 15 or so a year, and Thames Water are on site within 2 hours to rectify the problems. So that's the scoring system. Yeah, and as I say, it was provided initially by the Environment Agency as an addition to the assessment questions that were already identified within that good practice guidance. So for us, this is what follow-up looks like in London. Thames Water have a dedicated surface water outfall program. Not every water company has that, and they are funded to remediate 200 outfalls over a 5-year period. Water companies work on a 5-year investment cycle, asset management period they're called, or AMP. Yeah, 200. And actually initially when we started the outfall safari program, we wanted to investigate whether 200 outfalls over 5 years is enough, and it's not. It's still pitched roughly at that level, but it's on a sliding scale. If we find more, they will do more. Outfall safaris have now become the main source of data because it's sort of proactive surveys, whereas before they were relying on kind of just ad hoc reports from agency staff or members of the public. It's important to stress, though, that not all outfalls, unfortunately, are assets of the water company, and ownership is often disputed and complex. Yeah, so anyway, so Thames Water follow up, and they feed back to us what the follow-up is, and then we can pass that on to the partners that were involved in the safaris. I have to say, all this is, I stressed this before, but it's delivered in partnership, so we're leading it, but it's really dependent on that really helpful network of partners across the region. What are the other outputs? Well, you get those reports directly from the field, those acute problems that get resolved. We have a map of all the outfalls that we've assessed, impact score for each and the location of them, which hasn't necessarily already been done in some rivers, which is a bit shocking. It boosts collaboration between EA, water company, NGOs and the local community to get the dialogue going, to identify the right things that we need to be reporting from the river. You know, basically boosts capacity for communities to monitor these issues. And I think there's wider need for the data. You know, as that paper pointed out, there wasn't a systematic survey for these sorts of issues before, and there is now. And that's evidence that we can get that can inform policy management, and something else which is behind the toolbar there, which I can't see. So it allows us, you know, we need this data as the bedrock to create a strategy for tackling these issues. It allows us to identify hotspots within an urban region. It allows us to identify repeat offenders in terms of outfalls that get signed off, they get remediated, but they come back on the swap. And also, as I've pointed out, that we've realized it's not just about misconnections by any means. We've obviously got CSOs in there. This method isn't particularly for CSOs, but they will be scored. Cross connections, all these other issues, blockages. It's evidence that allows us to identify the relative contribution of these to degrading our rivers. And you know, there's a lot of focus at the moment on CSOs. The government just produced their stormwater discharge reduction plan. It's not good enough, and it's also for urban rivers. It's not necessarily going to help. CSOs, in some urban rivers, don't discharge that frequently, but you know, you can see from the data that we've produced 97 acute problems being recorded over the period that we've been surveying. They will have been discharging, a number of them probably for many years, contributing to serious problems in these rivers. They're not going to be impacted by the stormwater discharge reduction plan. So we need to identify the relative contribution, as I said, of these problems and then start tackling them. I'm really pleased that for us, the next steps, we're obviously working with Casco as well as the Riverfly Partnership and others on that great scheme, pulling everyone together to try and unify and take things forward together. So we're looking to support sort of outfall safari plus type schemes through Casco. We have produced guidance, which is downloadable on the CABA website. I'll give you the link in a minute. And if you use the basis of this, which, as I said, is very simple, it would be good if you call it an outfall safari, but there's all sorts of ways you can innovate this and tailor it to your local needs. And we'd love to hear back about how you do that and how you innovate and what the successes are and how we can improve it as well and where we use it in London. And we're also working with smarter water catchments ourselves to trial different ways of approaching the problem and to improve the system. We've realized that it's very difficult to compare like for like on this 4-year rotation we have. So Thames Water are referencing their outfalls. It's remarkable that they haven't done so already, but they're doing it now. It seems to be very, very complicated. And then we're going to pilot this year having their reference numbers, and that will allow us to more systematically monitor the outfalls over time. It'll be a very helpful step change. And also we're going to be taking out some ammonia sensors to subsample outfalls that don't show any evidence of pollution, just to check that actually we are detecting problems through this method. You know, simple as it is it actually the best data for us to get?
Couple of minutes, Joe.
Sorry, how long?
Couple of minutes.
Sorry about that, Steve. I'm waffling on. Anyway, limitations. Here are some of the limitations that we need to be aware of. The outfalls assessments are only as good as the training that you give. So we want robust data. Some outfalls pollute intermittently, so it's helpful that problem outfalls are adopted by local communities, keeping eyes on them. And then obviously the whole problem, the response is limited by the budgets available through water companies, ultimately with Ofwat's consent. So the key messages in these dying seconds, if you have an urban river, separate drainage system, I'd urge you to set up a systematic scheme to survey your outfalls, especially the out of sight ones. Please create it in dialogue with Environment Agency and, very importantly, with the water company that have the resource to follow up. Quality control your data as it comes in. Survey systematically and manage volunteer expectations. Change can be frustratingly slow, and that's why we have this 4-year cycle. These are the wonderful partners that we work with. We're currently funded in London and the Thames Valley by Thames Water, and that's the link for the guide. So thanks very much for listening. There's my email as well. Drop us a note.
That's great. Thanks, Joe. We have got a couple of minutes for questions. There are a couple of questions here. So Mark Williams has asked, is there any feed-in from Thames Water's EDM map?
There's no feed-in, but it's really important that they finally have that event duration monitoring. So this is monitoring on the CSOs, for those that you don't know what EDM is. It's really important that we have that, because as I say, I was talking about those sort of relative contribution of the impacts on particular catchments. Okay,
and Jane Prady asks, can you tell the cause of pollution from what you see?
When the more severe problems, not directly, no, but the more severe problems are generally blockages or those cross connections, the dilapidated, failing infrastructure. Yeah, it's not so sophisticated. I mean, misconnections generally score between 6 and 10 or so, and other problems, blockages, etc., score higher.
Okay, and a question from me actually. I was wondering how whether we can use outfall safaris to look at rural outfalls as well, like field drains and road runoff, that kind of thing.
I think it's certainly worth mapping those outfalls. I think that's the function of Mud Tracker. Okay. So, I mean, in rural areas, you've got sort of isolated septic tanks and the like, individual treatment systems which need to be monitored. They operate under license, but you know, we've had a few of them in London, and they are a problem. So there's definitely worthwhile, but you'd need to adapt the method to suit your local circumstances. This is particularly tailored to that separate drainage urban system. And of course, we're not just talking about rivers that are entirely urban. If you've got rivers that are largely rural but flow through urban centres, just apply this to that stretch on a period, you know, on a repeat basis. Yeah.
Okay. And Lauren Baker wanted to know, how can we organise outfall safari training volunteers for safari training for volunteers?
Actually, a few years ago, we ran a train the trainer, and we'd love to do it again. I think there is a need out there, and maybe this is something we can do through Casco. I'll have to pick that up with Michelle later. I think, you know, it is straightforward, but there's a few little things that's worth going to a training. So yeah, we'll try and organise that. It's a good question.
Brilliant. Okay, I think we'll move on now. There's just one more thing to do, which is the Volunteer of the Year award. I'm just going to share my screen. Hopefully you can all see that. Okay, just trying to, that's it. So I've got great pleasure in announcing the winner of the Richard Chadd Volunteer of the Year award. Richard Chadd, some of you may have known Richard. He unfortunately died about 18 months ago. It's a great shock to us all, and a great loss to the Riverfly Partnership, because Richard was a great champion of Riverfly and vigorously promoted it at the highest levels within the Environment Agency where he worked. He saw the value of citizen science and supported volunteers at every opportunity. It's therefore appropriate to dedicate this award to his memory. There have been 5 nominations for the award, but I'd really like to award the prize to all our volunteers, because, you know, they all made an enormous contribution in their own time, and really making the force of this volunteers on rivers being felt. There's a lot of stuff in the news these days about the problems on rivers, and also how citizens are really basically getting fed up with it all. So everybody's very special. However, let's move on to the nomination. So the 5 people who've been nominated are Howard Atkinson, who's based on the River Asker in Dorset, Keith Carpenter on the River Stour in Kent, Ian Hawkins on the River Lark in Cambridgeshire, Paul Jennings on the River Chess in Buckinghamshire, Angus Menzies for work in Dorset, and Jan and Phil Swan who are working in Somerset. So the award, we've decided to, it was a very difficult decision to make, as I'm sure you're aware. Everybody's made a great contribution, and these people in particular have been nominated. But we decided in the end to give the Richard Chadd Volunteer of the Year Award to Ian Hawkins. And he's won because, as well as supporting his own local group, goes above and beyond the local area by training volunteers in Riverfly throughout East Anglia and beyond. Ian's a strong advocate of Riverfly, raising its profile at talks and meetings with a wide range of organisations and politicians. He's a trained tutor in Army and in extended Riverfly and fully supports all aspects of Riverfly, but also inputs to the organisation with ideas of how to take Riverfly forward. So it's with great pleasure that I announce that Ian Hawkins is the first winner of the Richard Chadd Volunteer of the Year Award. Well done, Ian. Very well deserved. Okay, so that brings us to lunchtime. And wait a minute, here we go. Done that. So that brings us to lunchtime. So we're going to have a break now. We're going to reconvene at, oh, Ian's just said he's in Suffolk. I do beg his pardon about that. Well done. Right, so we're going to reconvene at 1 o'clock. Simon Johnson will be chairing the afternoon session, so we'll see you all at 1. Very good. Have a good lunch. Cheerio.
Good afternoon, everybody. Hope folk are suitably refreshed after the break. Welcome to the afternoon session. My name is Simon Johnson and I am Executive Director of Freshwater Biological Association. We have some fantastic and thought-provoking and very inspiring presentations this morning, and I think the future for the partnership is looking very bright indeed. What I've really taken away from this morning's session is that I feel we're now really building a platform to grow and develop the partnership. We've got the investment, we've got innovation, and most importantly, we've got over 1,000 river warriors who care enough about their rivers and want to generate and enable decisions and action, dare I say it, for a better planet. Inspiring and exciting times for sure. We need to keep to time, which is slightly rich coming from me and my previous history of overrunning in presentations, and I will endeavour to give folk a gentle nudge at 2 minutes. If you could try and bring your questions towards the end of each session, that would really help me. Anyone knows me, I'm not particularly technically gifted, so any help you can give me would be much appreciated. But please feel free to keep using the chat to exchange ideas and links as what's being happening all along. If we can't answer any of the questions today, we will endeavour to follow those up in a document later on to all participants. Just before we start, many of you will know and love Stuart Crofts, who is a tremendous ambassador, Riverfly champion and trainer on the Riverfly Partnership. Unfortunately, Stuart has been really not very well over the last few days. I'm pleased to report that he's now back on the mend, and if anyone knows Stuart, he's in good spirits. Just with your blessing though, I would really like this conference to send him our love and good wishes for a speedy recovery. So I'm just going to look for everyone to hit the heart button in the reactions before we get going, and I know Stuart will take great comfort and knowledge that we're all back in his return to the saddle as soon as possible. Thank you so much. So without further ado, I would like to introduce today's first speaker, who is Michelle Walker of the Rivers Trust, with a talk titled Citizen Science Opportunities under the CASCO project. Over to you, Michelle.
Thank you very much, Simon, and hopefully you can see my screen okay now. Yeah, thanks everybody. Really enjoyed the presentation so far today. It's just so inspiring to see what's going on, and yeah, I'm here from the Rivers Trust today to talk to you about the CASCO Citizen Science Project, which is looking to grow and expand a lot more of what we've seen already today. The CASCO stands for the Catchment Systems Thinking Co-operative, and a major part of this project is to develop a nationally coordinated citizen science initiative. So CASCO is a 3-year project. It started in September of last year and it's running until 2025. And so we're in the first year of the project, and I'll be talking to you about why we've developed it, what we've achieved so far, and most importantly, what's to come, where we're heading, including all of the opportunities that we're going to see for citizen scientists as we grow it. So, I mean, we've heard quite a bit today, and I'm sure everyone on the call is really familiar with the pretty sorry state our rivers are in. You know, we've got widespread pollution issues. I hope Joe's pictures didn't put you all off your lunch before, but yeah, this is something we see up and down the country, and we're seeing a staggering loss of wildlife and habitat as well. And, you know, we need data and evidence to tackle this problem, but that data and evidence is really thin on the ground, and it's getting thinner. This map here is one that we've produced for the team catchment in the headwaters of the Severn. And the grey areas are the water bodies within that catchment where there was no orthophosphate monitoring at all over the last year. And that's a picture that we're seeing replicated across the country as budgets get squeezed that we're seeing less and less monitoring from government. And that sort of evidence gap is really critical, but it becomes even more critical when we're trying to pick apart, you know, what are the causes of these problems? We need that data to target action and to measure improvement, because that's really critical for securing funding. And this means that we need certainty on what economic sectors and activities we need to change first. But this information is based on that declining national evidence base. And that chart on the right-hand side shows how certain the Environment Agency is overall about the causes of poor health in our rivers. And as you can see, we've got a lot of room for improvement in terms of increasing that certainty. So we really need to fill that evidence gap as well. And we've seen citizen science really sort of stepping in over the years to try and fill those knowledge gaps across the country. You know, some of the examples we've got today, I mean, Riverfly is a fantastic model in terms of being a national scheme with quality assurance protocols. We've got an awful lot of citizen science going on across the country, really fantastic initiatives, many of which we're hearing about today. And local communities already monitoring and surveying habitats and wildlife and water quality and pollution and the health of the wider catchment. And there's some really great examples of how you know, catchment partnerships are generating that locally derived evidence and combining citizen science data with professional monitoring and helping to improve the monitoring of river health, such as West Country Rivers Trust CSI programme we see. But there's a problem. There's a lot of citizen science schemes out there. There's so many data platforms and apps and maps and schemes and equipment that it can be very challenging for groups wanting to get involved to know where to start. But also it makes it really challenging to try and combine this data into easy to digest information that decision makers can access and use to identify the causes of problems, and more importantly, to make investment decisions to fix them. So it's also really hard to know whether data are trustworthy, because a lot of schemes don't have quality assurance protocols, or maybe they do, but they haven't documented them. And it's very hard to know whether you can trust that data. And all of this undermines the ability to find that ongoing sustainable funding. We've heard that a lot today. But it can be really challenging to fund this activity on an ongoing basis. So this is where Casco comes in. This started life a few years ago with quite a few of us who are on this conference today. We developed a proposal for a national catchment monitoring cooperative, as we were calling it then. And that eventually became a successful funding bid to the Innovation Fund. So we partnered with 12 water companies who could see the value of engaging their water company customers, that's all of us, in developing a more reliable evidence base that would help underpin future investment. And it was renamed Casco to reflect the fact that the evidence would be used for managing water company assets within whole catchment systems. So over the next few years, we're going to be collaborating with citizen science schemes and organisations, catchment partnerships, water companies and government to agree and develop standardised approaches and quality assurance systems. We'll also be investing in data platforms so that we reduce the number of different solutions and that we make it easier to combine citizen science data with other types of evidence, including professional monitoring and data from sensors and satellites. And we'll also be developing visualization tools and analyses that will help really interpret that data and evidence, combining different tiers of information into a weight of evidence to help policymakers, catchment managers and investors make better decisions about where to target river and catchment restoration. So we're operating Casco across England and Wales in 8 demonstration catchments. And these demos are sort of piloting the approach in a variety of settings. They've got lots of different themes so that we can get a really good representation of all the types of citizen science and data and evidence that we need. And we're going to be doing sort of two crucial things that we think will help the citizen science groups that are already active, those that are just starting, and those that are going to start up in the years to come. Firstly, it's about learning from each other. So what works well, what doesn't, the ability to sort of try out new things, such as which methods of measuring phosphate or ecology species work well, and what quality assurance protocols we need to use to get the data accepted by water companies, by the EA, by other organisations that make investment decisions. And we'll also be doing innovation, using things like low-cost sensors coupled with machine learning to really try and get the most out of the data and evidence we can gather. Working out what training volunteers need, how we can effectively store, interpret and share the data we collect to create change. And really looking at how we can measure the success of actions as well, and passing this learning on and meeting those common needs nationally where it's appropriate. And really our sort of long-term aim over the next decade or so is to really gear up, those thousands of people that are already active, let's really gear that up so we've got active citizen science groups in every county and every water body across the country, and grow it beyond England and Wales into Scotland and Ireland as well. But Casco is also about working together to gather data and improve the health of our rivers. So in each demo, we're forming a partnership comprising at least 3 members, which is the environmental NGOs that are generally hosting the catchment partnerships, the water company and the EA. And we're getting them to develop collaborative monitoring plans. So we heard about a great example earlier from John, where the EA and the water company and the NGOs and the Riverfly partners were agreeing who was going to collect what data and sharing it. That's exactly what we want. We want to sit down and agree those objectives and be strategic about where monitoring happens and how the data are gathered and shared. So it's really about learning from the demos, but then using that experience to develop systems that we can roll out nationally and way beyond the demos eventually. So we've got some objectives over the 3 years, and those broadly sort of break down. The first 3 are about really that working together to produce and roll out an agreed approach for monitoring, for training and for sharing data. And then the next 3 are really about that sort of learning from the demos and building that community of practice and measuring the wider benefits that we're doing as well. So it's not just about better data and evidence, but there are social and health and well-being benefits that come from getting people connected to nature, upskilling people, improving their job prospects. These are all fantastic things that we'd like to measure because we see them as being benefits that could bring in future funding. And the last 2 are really about making this business as usual. We've got to make this sustainable. And with all of that sort of information on the benefits and demonstrating the outcomes, we want to make this business as usual, really, and secure that long-term funding and make sure it becomes part of how we make decisions about our rivers. So the project's organised into 6 different work packages. We've started making headway across the board. It's a very challenging project to work on because we've got so many partners. 24 core funded partners, but we're now sort of over 30 engaged and working on the project, and more coming on board all the time. And in the demo catchments, we've already got volunteer coordinators who've been recruited and appointed, and lots of the demos have already started on their collaborative monitoring planning process. They're running things like water blitzes, where we have sort of concerted effort across 1 or 2 days to get lots of data, and lots of these are being planned for this year. We've been doing initial training, and we've started planning for River Watch, which I'll talk about shortly. And at the national level, we've done quite a lot of work developing our sort of long-term vision collaboratively, and drafting a charter, which are a set of principles that can underpin where we're going in the long term, even beyond Casco. So when we don't have a contract binding us anymore, how do we sort of collaboratively work towards this long-term vision? And we started work on the method audit as well, which is looking at across the board all of the different methods that are out there. So we're focusing on phosphate to begin with, and Joe Pecorelli, who you heard from earlier, is going to be starting work on fish method audit soon. And we've got River Restoration Centre going to be looking at habitat. So we're sort of picking off thematic areas to get started on, but also taking feedback from the demo catchments about where the priorities lie, because we can't do everything at once, but it's sort of innovation. So we're pathfinding and working out the best way to approach this and agree it collaboratively. We started work as well with the data platforms working group, looking at all the platforms that are out there, starting to figure out how best we can use the money that we've got to invest in the ones that exist and join them up. And we started assessing training needs as well, ready for when we get the work package on training up and running. So this year, the demo catchments will be gearing up many more of those citizen science activities, including water blitzes, where we're going to be doing sort of intense data gathering over a short time frame, as well as getting volunteers involved with other things like sensor maintenance and community modelling, engaging them in how the data are actually being used and applied. And in coming years, we'll standardise this activity, but the first year is really about trying lots of things, being able to benchmark things alongside each other, gathering as much structured feedback as we can on what works and what doesn't. But yeah, we want to improve the quality of the data, make things more accessible and useful to everyone, and really broaden the number of people that we can get involved in citizen science as well. And that's where Riverwatch comes in. So this is something that we're going to try out as a introductory citizen science activity, really. So it's aimed at people perhaps who've never done any citizen science before, looking to increase the diversity of participation in citizen science. So it's going to be very entry level, you won't need any training. And it's really about connecting people to their rivers, getting them to spend just 10 or 15 minutes by the riverbank and observing a few key metrics, things like wildlife and pollution and issues, as well as, finding out about their experience of the river. And really, we want to use this to raise awareness of what a healthy river looks like. We've heard a lot about the sort of shifting baseline syndrome, and I think a lot of people don't realise that the river that they're looking at is actually in pretty poor health. So we really want to sort of educate it, but also celebrate rivers as well, and get people really engaged with what they can mean. This will be a gateway then for further engagement. So hopefully people will get interested and maybe want to learn more and involved with some of the other citizen science opportunities. Using it to also generate useful data about river health, especially when we can combine it with those other sort of tiers of information. So we'll be trialling this in the spring in a small way in the demos, just to learn from it, and then looking to start to develop it as a national app that could be used everywhere across the country later this year and into next. I'm looking to collaborate with organisations to do it as well. So we've got some pretty long-term aims as well as those sort of short-term objectives. We want this to grow way beyond the 3 years. We see Casco as the seed corn funding really for a transformational change that we want to make. We've agreed a sort of collaborative mission and a long-term vision as well. We developed that with about 80 of us in a collaborative workshop, which was amazing to see how we could sort of form that long-term aim. But we want, above all, we want to sort of demonstrate the value of what we're doing so that we can secure that long-term sustainable funding to get sort of active citizen science in every water body across the country, and to integrate this into business as usual for the partners. So, you know, ultimately we want Casco to help us move towards that long-term change, you know, healthier rivers that benefit wildlife and the people that use them, and really engage, you know, citizens and communities in helping to deliver that vision. So that's all from me, and you've got my contact email at the bottom. I'd be really happy to answer any questions today, or if you want to get in touch after. Thank you very much.
Thank you, Michelle. Brilliant. Just whilst we are waiting for Rebecca to join us, a couple of questions here. Christian Kent, keen to contribute angling, trust water quality, citizen science. Who is the best person to talk to at Casco? Is that you, Michelle, for Christian to contact you?
Yeah, I think, Christian, you might have been in touch with Jessie previously. So yeah, just get back in touch with us. We've had, as you can imagine, there's a lot of organisations that have been in touch. So please don't take it that we're not interested if we haven't followed up recently. We're trying to spin off an awful lot at the moment. But yeah, do ping me another email. We'll set up another call. We're sort of trying to spin off quite a few meetings with different organisations to see how we can bring what you're already doing into Casco and develop it together. So yeah, reach out to me in the first instance and pick things up.
Great stuff. Okay, and one more, and then we'll come back to these at the end of Rebecca's presentation. Watching Michelle's presentation, how do you successfully manage Casco on an operational and into other areas of the UK? Who goes to the remote places?
Yeah, I mean, that's going to be a real challenge, is how we sort of fill those gaps in the map. And particularly, you know, we'll be juggling the kind of need to be inclusive and increase diversity, which means, you know, we can't rely on people only living in rural areas who have access to cars. I mean, these are all challenges I can't tell you the answer to right now. This is what Casco is about. It's how do we do this? How do we make sure that we can have reliable information, but also the right sort of spatial and temporal coverage? You know, we've got to wrestle. There's a lot of citizen science schemes out there, for example, that don't want to be prescriptive and don't want to tell people where to go and collect data. We want them to choose, but then how do you balance that with making sure that the data can address the questions you have, which may need spatial targeting? So I think these are all really good questions, and watch this space. Hopefully we'll be tackling a lot of that. You know, we've got task and finish groups focused on things like diversity and inclusion, recruitment and retention of volunteers, health and safety, you know, GDPR, data privacy. There's lots of issues that we're going to be sort of focusing on over the next few years.
Okay, thanks, Michelle. Thanks. If we can't get to all these questions today, please be assured we have a record of them, and we will fire them out to the various folk that you're targeting them out. So thanks, Michelle. So without next speaker on the today's menu is Rebecca Lewis of Buglife, who's joining us to talk about connecting communities through riverfly monitoring in Scotland. Over to you, Rebecca.
Thanks very much, Simon. Can you hear me okay? Yep.
Yeah, I can hear you.
Thank you. Brilliant. Okay, let's see if I can be successful at sharing my screen as well. Okay. So hi, I did say thank you very much for having me along. I'm absolutely delighted to be here to talk about our new project that we have launched through Buglife. I'd also like to take the opportunity to say congratulations to Ian Hawkins. He was great at supporting and communicating with me from afar when I started my journey with Riverfly. So it's nice to see that acknowledged today as well. So my name is Rebecca. I am a conservation officer working for Buglife for the last couple of years. I also am a communications post for the Scottish Freshwater Group. And I'm also Riverfly Partnership trainer, one of two currently active in Scotland. And I've been doing that over the last possibly 4 years now. So I'm here to discuss the launch of our new project through Buglife, working in partnership with the Riverfly Partnership itself. And I want to discuss how we're aiming to try and connect communities through riverfly monitoring in Scotland. So just in brief, who is Buglife? For those who don't know, we're the only organisation in Europe concerned with the conservation of all invertebrates. And our aim is to halt invertebrate extinctions and achieve sustainable populations of invertebrates in the UK. And with current declines in invertebrates, it seems like rather a big job. But with projects like Guardians and others we're hearing about today, we have the unique opportunity to try and get everybody involved, increasing the understanding of what helps keep our rivers in good condition and ways in which communities can support this. So Riverfly monitoring in Scotland. So what's been going on? So in July 2003, the River Tweed Foundation organised training courses. I've just encircled it down there. The first ones with Riverfly monitoring. In 2006, the Riverfly Partnership was presented to the Scottish Environmental Protection Agency. And in 2007, it was formally endorsed the programme. A major step forward was 2012 was a project called CRIMP, which was launched by the Clyde River Foundation, and that drastically increased the numbers of Riverfly groups in Scotland. So you can see kind of a trail moving down from the central belt there with all of the groups that were involved. So from the 34 Riverfly monitoring groups registered, this incorporated 184 sampling sites. And you can just see from the little map inlaid there where the kind of very rough orange line was the border between North Scotland and England. You can see the density of Riverfly groups compared to that in Scotland and the kind of spread that we were finding them. So during this time, the SEPA had about 0.5 days a week to actually support this training within the agency itself. So active groups at the moment are currently classed as those who've submitted data in the last 3 years. This gives a bit of a COVID allowance. So we do have some groups still going, but there may be a gap from when they've been submitting their data. So with Guardians of Our Rivers, we're looking forward to really rebuilding and expanding this network in Scotland and supplying a bit of a support hub on the ground through Buglife. So why Scotland, you ask? So here's a picture showing the kind of glorious spread of Scotland right up there to Shetland at the top of the map there. But if I pop up this map, that really helps to answer the question why. So with approximately 125,000 kilometres of rivers in Scotland, from fast and furious, steeply flowing burns to kind of wide meandering rivers, there's a great range of rivers and burns, really is fascinating across our country. And with such a variety of river types provides Scotland with a great diversity of river habitats and landscapes. And, you know, if you took a pair of scissors and cut across all the rivers there that you see following the blue lines, you just end up with a shard of little bits of white paper. So it really is important for the ecology right across the country. So we are seeing the effects of climate change. Last summer, the north and west of the country experienced its driest April to September in 160 years, while for the whole country, it was the second driest on record for the same period. So with a decrease in summer rainfall expected, we have to be prepared for increased pressure on Scotland's water resources. And perhaps in places we've never had to deal with water scarcity before. And this was a statement from SEPA in 2022 there. But also, as the world warms, the UK is likely to have more hotter, drier summers, warmer, wetter winters, according to the Met Office. So extreme weather events such as heat waves, heavy downpours become more frequent and more intense. So Guardians of Our Rivers. So this project aims to connect individuals and communities across Scotland with their local river catchment. We'll ensure that communities feel rooted to their local environment and connected to their local communities both up and downstream. We want to share learning across the projects and groups so they'll feel part of this bigger picture, protecting the health of our rivers systems against the global threats like climate change, so that hope that they'll embrace becoming river guardians. So through training and support, the communities will then kind of be empowered to monitor the rivers and to gather information that they will benefit all people, businesses, wildlife that rely on rivers and their catchments. So this information can feed into any future conservation and then community relation projects that they might have. So how are we going to do this in bullet points? So we're going to use the well-established Army citizen science training provided by the Riverfly Partnership from its mothership, the FBA. So we'll be providing training packs, advice on things like site location. We're going to also help provide a starter kit to groups with limited or no funding to kind of help them get started on this journey. You know, there's a lot of groups that have started with funding in their pockets that's enabled them to buy this kit to get out and do stuff, and that's missing a lot of smaller community groups who are really keen and up and rising that don't yet have the funds. So we're kind of supplying the whole kit, the training, the packs, and a starter kit to get them out and get them going. So from that point, we're going to provide ongoing support through our Scottish hub, supported by the Riverfly Partnership, and we'll be there for any ongoing questions and help that they need on the ground. So what's it all about? I think everybody here is very familiar with that. So a lot of the conversations I've been having through numerous meetings, I ask them what it is that they want. We want our advice to be kind of bespoke to the projects that they have there already. So restoration, the picture on the left-hand side is a part of a restoration that we've been doing as part of a Riverfly group locally. So small and large-scale projects are happening and about to come online this year and going forward with restoration, from smaller local projects that might be looking at litter clearing and small-scale tree planting, to then the larger projects that are looking at remeandering, planting, barrier removal, and also several kind of rewilding projects. So there's a lot of restoration coming that the community can get engaged with through monitoring their own rivers. Pollution, of course, is the big one, the picture in the middle. If you're going on a fast-paced walk with your dog along the river, you might not notice the small blue pipe in the middle. And Joe was talking about the fantastic outfall safari program that they have to pick up these things. So on our local river, you know, we've got sewage, mine water, fly tipping, and these are the three kind of main issues that are coming up in conversations with the groups that I've been talking to. So it allows us to get out and feel they're part of the solution and keeping an eye out on what's going on. But of course, there's the social. Got a fabulous picture on the right-hand side, and this is a local group that I coordinate who turned out with flasks of hot drink and cakes that day for our monthly Riverfly monitoring. So, apparently, you know, getting out in nature. I mean, we all know it's such a healing thing to do, and we found this especially important during COVID-19 when people were going out about in our local environment. But volunteers join for a lot of different reasons. And with this brings a variety of people with a joint love of spending time outdoors. But it also brings in some really, really interesting questions that can help you kind of focus your local project and add some variety into it that way. So I guess for me particularly, this journey started I became a volunteer myself on a project that was started in 2019 as part of a community engagement. So I was one of the 12 people that was trained by a qualified Riverfly Partnership trainer. And then Riverfly on the Esk was formed, and I kind of took the reins and built this up. We now have 16 monitoring sites and 51 trained volunteers. So we are kind of looking at catchment scale monitoring now, and PowerPoint seems to have swallowed two of my markers, but you know, there's a couple more in there. And at catchment scale, you have the ability to kind of pinpoint pollution and use your team to follow it downstream. We've had a couple of incidences in the last year. The most recent, I had the team send me a message early in the morning going, oh, the the Facebook forums are saying that they've got pollution in this area. And so I messaged the team further down towards the estuary and said, look, can you keep an eye out if you see something travelling down your way? So of course they were both out before breakfast and both out at lunchtime because they're dead keen. Unfortunately, it didn't travel that far, but it gives you an idea of, of how this can work in the ground and how we're really getting people involved in caring for their rivers and connecting them there. So since it started, we have now carried out over 170 surveys with volunteers and 6 months worth of water sampling. So we were lucky enough to get a little bit of funding. Someone asked about that earlier. We went to our local council. They have small grants, so we applied for one of them. And we joined the Freshwater Watch's fabulous water sampling programme. And yeah, so we got the results coming in there. We have several new sites starting up this year, including 2 new on the southwest to complete our catchment scale monitoring. And we've also planted 230 trees along a problem bank, working with the landowner who was very concerned about one of the tributaries. It was a particular pollution problem. And we've also linked in with local volunteer schemes. So lots of businesses and organisations have a certain amount of volunteering time a year. So we've been getting them out and showing them the river and hoping that they'll become more involved. We've also contributed to local events where we've been asked about joining some green prescribing projects. We're also run joint events with Marine Conservation Society, so looking at the journey from the rivers to the sea, joining freshwater citizen science with marine citizen science. So I'm excited that's happening in April. We've also worked with universities, mentored master's students looking at the new extended scheme, for example, and we're looking ahead to some innovative techniques to trial on the Esk itself, along with another river in Scotland. We've published a few papers, delivered numerous presentations, both locally and nationally, and it really has raised awareness of a river being the heart of the community. So as I say, the Riverfly on the Esk was a bit of a springboard for me, and started working at Buglife, and we've come up with this new project which we're very excited about, which launched in October last year, which seems forever ago. And since its launch in October, we have received over 220 expressions of interest in the programme from across Scotland. And this covers 19 council areas, 8 schools, 33 potential different community groups, and 29 rivers. We originally kind of thought, we'll go for 15 groups over 2 years. So we completely inundated, which is brilliant. And as I say, we're very excited about this and the possibilities ahead. I've already completed training for one of the groups and started training 3 hours. We've also done local workshops, some presentations and events. And I have been personally meeting with volunteers. I've met with 82 volunteers over 35 meetings since the launch of the project. And the idea is really just to speak to people. You know, everybody's got a different idea of how it's going to work within their project. We're not coming in to take over the project. We're coming to help support and contribute to what they're doing, and seeing how Riverfly can fit into the information that they want to gather. What's been particularly exciting is the schools that are interested in getting involved. So I've started training my first school already. We're halfway through. So the idea is that schools within the areas will adopt a site on their river, and therefore widen that community engagement, so that the teachers will do the training themselves. And going forwards, as the kids pass through, they can be bringing the data and the information into the classroom, and continuing to learn about the river, and having a river theme and a project that runs throughout the years, making it a bit more sustainable. So yeah, we're hoping to get some more schools going through the training for their teachers. So why do people take part, and what makes them stay? Well, that's the eternal question, and if anyone wants to put the answer in the chat, I'd be most grateful. But you know, there's lots of common reasons, as you can see the graph on the left-hand side there. some less common, some very rare and some rare. But some of the key in the bullet points on the right-hand side are what's coming back to me from speaking to the groups that were no longer running. A lot of it was about the lack of support. They wanted to have someone nearby that they could send a picture of a bug and say, I'm not quite sure if this is still the same one I'm looking at. So they wanted that level of support on the ground. So they were, looking forward to having the hub in Scotland. Learning as well, is there a learning journey that we have associated with this? Some people come in very gung-ho, they'll do army, but they just want more. So of course we've got the fantastic extended Riverfly Partnership monitoring now, as well as the urban. So we've got different options to add on to that learning journey. But also the other fantastic projects that people have talked about, like Outfall Safari and Freshwater Watch and more. There's lots of different programs that we can signpost as well. And the level of interest, making it interesting. What are we doing on the ground with your project? How else can we involve our community? Can we do workshops? I had one of my volunteers saying, I want to come and do a talk. So I sent them all information about the local group, I've got an art teacher who drew an absolutely beautiful drawing of a stonefly, and we put it together in a paper and published it. So it's just, honing in on individual interests and what they want to get from it. Impact is a huge one, of course. You spend months on end going and collecting this data. Is it going to help the river? And that's another thing that people really, really want to know. So we're working with the Scottish Environmental Protection Agency, and we want to strengthen that bond and be seeing feedback and reactions happen when there's something going on in the river.
2 minutes, Rebecca.
Thank you. I'm always there. Opportunities as well. Like where can this take you? How else can we get involved? And for some volunteers, it's been a pathway into a career change. Friendship. Everyone meeting on the river together and getting to meet people in their local community and making new friends, but also to be a positive experience. We know that our rivers are often in a bad state, but people often want to come along and feel they're doing something positive, or you're making a difference, or connecting to net zero and increasing biodiversity, but they want it all and up to be positive. So looking ahead, so of course we've kind of briefly talked through that we're going to offer group support, and we've got the fantastic Riverfly Partnership resources as well, and the support from them. And in Scotland, we're hoping to provide an on-the-ground hub for people in new groups in Scotland. I discussed the learning journey, so we're going to be providing extra training when they're ready, signposting to other organisations that can offer other opportunities for doing more citizen science. Continue to offer training to new groups as they grow, maybe refresher sessions along the way, and also networking. So bringing all the different groups together in catchment areas and connecting them up to build this sort of big networking opportunity. Okay, so I'd just like to say a huge thank you to our funders, Squire Charitable Trust, Highlands and Islands Environment Foundation, Hugh Fraser Foundation, Norwich Trust, and Animal Friends, and of course to the fantastic volunteers and everyone who's engaged in the programme, and again to the Riverfly Partnership and the FBA for providing all the support and working with us along the way on this project. And I'll just sign off with one final note here to say, you think there's no Gammarus in your sample, you just have to look again, because they're always hiding. All right, thank you very much.
Thank you so much, Rebecca. That was a wonderful, wonderful example of the power of people. I can't see any questions in the chat specifically, unless I'm missing something. Someone's going to say there are, but I can't see any. I think there's a collective challenge for us all, just reflecting on the kind of CASTCO in your presentation, Rebecca, about how are we going to start connecting with audiences not normally associated with citizen science. I'm particularly thinking of BAME communities and those in urban areas. We've I've seen lots of photos of citizen science over the last months and years, and there's an awful lot of white folk in those pictures. And I'm hoping that we can start to address that and make citizen science attractive to all. I just wondered if you have any quick comments on that.
Yeah, I guess for us that was very much on our minds. It's a really important point, Simon, and I completely agree. And I think part of our engagement, we wanted to go for the smaller groups as well, rather than your classic people who are always engaged in the process. And I am seeing some of them come forward, but I guess supplying the kit as well to help them get kick-started. And I've been giving a few workshops to early learning and children coming in from difficult backgrounds, and I think that's a way of them coming home and talking about it with their parents and trying to then bring them in. But yeah, I can't say we've cracked it, but we'll give it our best shot. But yeah, it's an important conversation to have.
Very much a collective challenge for us all. We all work in a sector that is not particularly well represented, and I'm really hoping over the coming years that we address this urgent issue, I would say. Do you have anything to add, Michelle, before we move on?
Yeah, I was just going to say, one of the things that we're trying is sort of being more proactive at reaching out, and we've partnered with Birmingham City University, which is the most diverse higher education setting in the country, and we've got, you know, a whole bunch of their students set on a challenge now to develop. This is their engineering group as well, so it's reaching out beyond the sort of people who were typically interested in the environment. And they've been testing out sort of prototypes of Riverwatch with their, you know, inner city kind of communities, and developing sort of novel monitoring kit and things like that. So we're finding that's, you know, a good first step. And we've certainly seen around the Rivers Trust movement some really good work from people like Don Rivers Trust and Ribble Rivers Trust. You know, little sort of tips and tricks for how to sort of, you know, go out and reach out wider and get communities that haven't typically been involved much more engaged. So that's one of the things Casco wants to do, is harvest all of that best practice, put things together so you can easily kind of see a list of ideas and go, oh, that's a good thing, I could try that. Yeah, I think, you know, working with social prescribing now as well is going to be a really great way to sort of reach out to people and provide benefits, you know, in return for getting people connected to nature.
Fantastic, thanks, Michelle. I think there's a real opportunity to work with kids at the kind of pre-GCSE stage as well, to show them that aquatic ecology is really cool and well worth going into. Okay, thank you both for those excellent presentations. I'm now going to hand over to Steve Omerod. Steve is based at the Water Research Institute at Cardiff University. He's also a scientific fellow at the Freshwater Biological Association, and the title of Steve's talk is The Changing Cocktail of River Pollutants and the Challenges for Citizen Science. Thanks, Steve.
Thank you, Simon, and just apologies for slightly jumping the gun and putting my presentation up there. I mean, having been involved with the Riverfly Partnership steering group for 17 years, I've just done the calculation. It's been absolutely tremendous to see the growth and enthusiasm in the way that this whole area of citizen science has developed. Really, really fantastic stuff today. What I want to try and convey in this presentation is around the increasingly complex environment in which we all work, in which citizen science takes place. I want to say something about the evolving challenges that come from that, but also at the end, make the point that some of these are opportunities. I guess all of us are aware, sorry, my screen is, all of us are aware that there is an incredible spotlight being shone on the river environment at present. These are just a collage of images that have emerged dominantly in Wales over the past year or two. And speaking as someone who's also involved as a non-executive director of a regulatory body, this is something that we are just as concerned about as citizens are. But you know, these are some of the things that not only provide the opportunity for amateurs, citizen scientists to be involved, but they also exercise professionals. And I've been involved in looking at global change effects on river environments now for 43 years, since I was a master's student in 1980. And my work has very much been around trying to understand through different types of river organisms just what the effects of different global change processes are in the long term, and very often over extensive scales. What I think a lot of this shows us is that we are living in a changing environment. So these are all chemical data collected since the 1980s through to the present day at our Llynbrioni Stream Observatory in a remote area of central Wales. They illustrate that there has been progressive recovery from the former problem of acid rain, which was at its peak in the 1970s. And in conjunction with looking at this increase in pH that's come as streams have recovered chemically from acidification, we've also looked at using invertebrates to tell us something about the biological recovery processes that have gone on. So by looking at the species we have present in our array of 14 streams, different types of streams, both at Llynbrioni and regionally across Wales, we can see that there is a slow but progressive recolonization of those formerly acid streams by organisms that have no tolerance for acid conditions. And John Davy-Bowker talked a little bit this morning about specific ways of looking at diagnosing the effects of acidity on groups of organisms. The data we have, and if I could ask you just to look at the top right-hand figure encased in a red box, those data, for example, show us that different species of invertebrates have different pH tolerances, they occur under different conditions, and we can use that kind of indicator system to diagnose just where acidity is responsible for changing communities of riverflies, of river organisms. Now, however, one of the things that emerges the longer that we've looked at the Llynbrioni data is that recovery from acidification isn't the only problem that we're dealing with. It's not the only process that's occurring. And if you look at these long-term data on temperature from the streams at Llynbrioni, the top two figures illustrate that both mean and maximum stream temperatures have been progressively increasing over the duration of the Llynbrioni experiment starting in 1981. And we're increasingly seeing that change in temperature is also matched by a whole range of changes among stream organisms. So for example, we know that abundances of invertebrates in all our stream types have been progressively declining from the 1980s through to the present day. And it's the cold adapted species, when we look at the traits of those organisms we're interested in, the cold adapted species are the ones that are declining most rapidly. And amongst that group of organisms, there's something like a 40% reduction in abundance across interannual data, 40 years of data since the 1980s. We're dealing with a set of circumstances where there are multiple stressors in operation, and that makes diagnosis actually quite difficult. We can see similar kind of trends if we look in the urban river environment. So these are some data we published using very large data sets from the regulators back in 2012, looking, for example, through richness and the contributions made by different species to river communities, just how recovery from the gross organic pollution problems of the past had developed over this 20-year period. So very, very substantial changes to wastewater treatment processes brought in by the Urban Wastewater Treatment Directive in the early 1990s has led to widespread reductions in insanitary pollution. And in fact, it's that recovery process that has given rise to opportunities for organisms like Atlantic salmon and clean water insects and dippers and otters to recolonize some of the urban rivers across England and Wales and also Scotland. And now, of course, we know that some of these trends are not necessarily continuing through time. There's a bit of evidence now that otters are declining. We've got really serious evidence of declines among Atlantic salmon. But nevertheless, when we look at the continuing pattern of recovery from insanitary pollution, we've just updated this analysis to 2020. We can see that richness of organisms has continued to increase in rivers across England and Wales. Composition is still increasing, it's still changing in ways that are consistent with recovery from gross pollution. But if you look at the right-hand side of the right-hand figure, that rate of recovery has slowed. So to a certain extent, this doesn't quite match the narrative of substantial concern around, for example, insanitary effects by CSOs, but it does raise some questions about why trends most recently might now be slowing down. It's clear that there are spatial patterns in the way that rivers across England and Wales are actually changing. This figure illustrates essentially two things: one, trends through time, the other, how those trends actually link to the amount of urban land cover. It's still our urban water bodies that are recovering from past pollution more rapidly, but equally there are some trends also occurring along rural waters. I'm not going to talk about those today, but I do want to just probe a little bit why recovery from past gross pollution might now be slowing down a little bit. Now we have, again, as John Davy-Bowker pointed out this morning, there are indicator systems that help us to score the tolerances of invertebrates to organic pollution. Those form the basis of things like the ARMI system. They form the basis of diagnostic methods of looking at what type of river communities are present and what that tells us about pollution. But again, the pollution environment in urban rivers is changing. And we became quite interested in Wales in this quite early on in the debate back in 2008. Barbara Kasperik-Hoydren, at that stage working from the University of South Wales, published data that pharmaceuticals were quite widespread in the rivers of South Wales. Other professional scientists have followed this up, looking at pharmaceuticals elsewhere, also looking at things like veterinary flea treatment products. And we decided about 3 years ago to look at this problem again, specifically in the rivers of South Wales, just to look at what spatial patterns actually look like. So we picked out two rivers where we wanted to do this analysis. One was along the main River Taff and some of its tributaries, going from the headwaters right the way down to Cardiff and Cardiff Bay. And we also wanted to use as what we thought was a reference river, this small urban stream called Roath Brook, which I can almost see from my window here, where we knew that there was no wastewater treatment input, but where we thought that access by people walking dogs, for example, could increase the risk of pet flea treatment products reaching those rivers. So we had what we thought were two contrasting environments where only one, we thought, was affected by wastewater treatment. Well, the data we collected from a whole range of different pharmaceutical compounds indicated that in fact pharmaceuticals are pretty much everywhere in the systems we were looking at. We also found a tremendous array of different pharmaceutical compounds present, some of them present in up to 95% of our samples, and pretty much any medication that anyone ever takes, psychiatric medications, cardiac medications, painkillers, and also evidence here of insecticides, and in particular, pet flea treatments occurring. All this slide illustrates is just what a wide array of chemicals are actually present in our river environments. We also looked at spatial pattern, and what we're looking at here is the aggregate concentration of along the two different rivers of all the pharmaceuticals we found. On the right-hand side, the main River Taff, illustrating that downstream of Kilfunith wastewater treatment works, there is this dramatic increase in concentrations of combined pharmaceutical compounds, And I've just picked out a couple there: erythromycin, fexofenadine, which is taken for allergies. And you'll see also the big red bar indicates the presence of caffeine, of course, which comes from human use and passes out through excretory systems and is a very useful tracer of where some of these compounds are actually arising from. But if I could ask you to look at the left-hand figure of Roth Brook, which we wanted to use as a reference, you'll see that there is also very clear evidence of the occurrence not just of caffeine, which again reflects human use, but also pretty much the same range of pharmaceutical products that we found in the main TAF. Concentrations are not actually statistically significantly different from the TAF. They're almost as high in absolute terms. So here's a puzzle. Here's a stream system which has no obvious wastewater treatment works emptying into it. But what does occur in this system is that we have something like 8 or 10 different surface drains that empty into Roth Brook. And what we think is happening is that people's household domestic releases, either from toilets or from washing machines or from wash basins or from showers, are misconnected to the surface drain system rather than to the foul sewer. So a little bit similar to the story we heard about sewage fungus earlier on this morning. Something like 5% of households actually have their sewers, their foul drainage misconnected to surface drains rather than to sewer. In the worst possible locations, it goes up to about 25%. And very clearly here, we are seeing the detection of the consequences in this small river environment. Now, of course, again, there's a kind of really significant question in all of this about just what these compounds might do in ecological terms. And the ones that we understand most clearly at the moment are the pet flea treatment products. So here's my own dog, Leo. He isn't given either fipronil or imidacloprid, but vets now routinely prescribe to dogs and cats and also rabbits a pet flea treatment, which is very often a spot-on or a pour-on compound, something like fipronil. We know a little bit about the toxicity of these compounds to organisms from laboratory toxicity tests. And what our data shows us, both from the Roth Brook and from the main TAF, is that the concentrations of fipronil, sulfone in particular, and also fipronil, are actually reaching those where it's actually possible that chronic predicted no effect concentrations are actually being exceeded. So here we are, we're in this set of circumstances where there has been recovery from gross pollution problems in the past, but we've now got evidence that emerging contaminants, new kinds of chemicals, could be actually adding to or making more complex the response of river organisms to the pollutants that are actually present. And just one other small point, we've also looked a little bit at occurrences of microplastics in the Taff, the Usk, the Wye rivers in South Wales in general. And we kind of hypothesized that CSOs, combined sewer overflows, wastewater treatment works could be a source of that material. It could be finding its way through to invertebrates. It could be passing through food webs to reach birds like the dipper. And if so doing, it could be toxic in its own right. It could be physically damaging. It could be transporting some of these other chemicals. And we published this paper based on work in 2016, illustrating that 1 in every 2 of the insects in the Taff and the Wye and the Usk system are actually contaminated by microplastics. Dippers, we can calculate, are ingesting about 200 fragments of microplastic every day. They're feeding to their chicks thousands of fragments of microplastics before the chicks emerge. At the moment, we don't have any evidence that there are adverse effects, but clearly this is an area of extreme concern given the increasing tonnages of plastic waste that now enter rivers in Britain and elsewhere over the annual cycle. So if I can come to some conclusions from all of this, it's clear that the kind of ecological influences that occur on river systems are changing. They're very clearly evolving. Not everything is negative, but this is an increasingly complex circumstance in which river monitoring for professionals and amateurs alike takes place. Quite a lot of the patterns we don't yet fully understand in time and space. We need to know more, for example, about veterinary pharmaceuticals in rural river environments. We need to know more about how some of these chemicals behave under different flow conditions and, for example, with climate change. So, you know, we're some way from understanding just how serious these effects are, but it is an emerging risk. And I think this brings some challenges for citizen scientists. If people, for example, are trying to do water quality assessments using test kits for phosphorus, if we were to try and develop test kits for pharmaceuticals, it would be hugely expensive. These are very, very expensive analyses. So there is a complex set of circumstances to interpret and to diagnose that I think we all should be aware of. Now, at the same time, there are really significant opportunities here. There is absolutely unprecedented interest in rivers, their status, and the need for us all, I think, to do more, to look more, to determine where problems are arising. And if I go back to my example of pharmaceuticals in Roath Brook, at the point where concentrations of pharmaceuticals increase, there is a very substantial reduction in the richness and a very big change in the community composition among aquatic invertebrates that probably would be detected by certainly advanced riverfly monitoring. So there is an opportunity for development and to try and get on top of some of these emerging complex problems. So at that point, Simon, I will bring my presentation to an end and stop sharing my screen.
Thank you very much, Steve. A minute ahead of time, ever the professional. Great presentation, complexity, challenges and opportunities, particularly impactful but rather depressing statistic of 200 microplastic per day per dipper is something that if that's not a sobering statistic to take away from today, I don't know what is. So brilliant presentation, Steve. I can't see any. Oh, I've got a quick question for Steve. Fantastic story. Can you say whether fipronil is likely getting into the river from pets swimming in rivers or through wastewater from homes? I think you've probably answered that to a certain extent in your presentation.
Yeah, I mean, the evidence is that it's through the wastewater treatment system from things like pets being washed at home. Our data from Roath Brook illustrates that the locations where pets swim in the river have very low concentration. When you get downstream of sewage inputs, then they actually go. I should say that there has been some pushback on this from the veterinary pharmaceutical industry, who make the point that lots of people have things in their homes that could have been treated by insecticides used in pet flea treatments. You know, if they've bought furnishings, for example, that have come from overseas. So that is a bit of an argument that's going on between Rosie Perkins, Dave Goulson, the people who published the initial data, and what the veterinary pharmaceutical industry would like us to believe.
Thanks, Steve. There's a couple more questions which I'm sure we can do after the next speaker, if you'd like to join us at that point again, Steve. Thank you very much. Our next speaker is Craig McAdam of Buglife, and also a fellow of the Freshwater Biological Association. And the title of Craig's talk is The Impact of I can't even pronounce this word, and fipronil flea treatments on riverflies. Could you just help me out there, Craig?
Neonicotinoids, but I've not put it on my slide.
I haven't got my false teeth in today. So anyway, I'll hand you over and take it away, Craig.
Thanks, Simon. And Steve has slightly stolen my thunder on this, but I'll continue anyway. Thanks for inviting me to speak here. It's a great honour to speak to so many people about riverflies. I'm Craig McAdam. I'm Conservation Director with Buglife, and as Rebecca has already explained, Buglife is the only organisation in Europe concerned with the conservation of all invertebrates. We cover everything from spiders to starfish, mollusks to mayflies, and our aim is to halt invertebrate extinctions and achieve sustainable populations of invertebrates in the UK. We do this through a number of activities. We inspire others by introducing them to the world of invertebrates around them, take them out and actually show them the invertebrates in their habitat. We undertake practical conservation activities, such as this bog restoration work in the top right of that slide there, and the creation of wildflower areas for pollinators, for example. We shape policy through advocacy efforts and the development of position papers and strategies. And we raise awareness through walks and talks like this here, also workshops and media stories. And we do lots of training and various other things as well. We published a freshwater strategy a few years ago now, which has 8 broad principles, not for Buglife necessarily, but for everyone, how we believe freshwater should be managed for the good of the invertebrates that are in them. You can see them there, and the one that I'm particularly going to talk about is number 7, which is about ecosystem health. So what I'm going to do is just to have a quick look at river flies in general and the declines that we're seeing in them, just to set the context, and then I'm going to talk a bit about flea treatments. Recent research in the Netherlands has pointed to declines in quite a few different insect groups, and in this paper from 2019, they analysed the bycatch in moth traps, looked at adult insects over a 10-year period, and this showed declines in caddisflies and mayflies, a 9% decline in abundance per year for caddisflies, and a 12% decline in abundance for mayflies. And this is an abundance. This is the number of insects in these traps. The results for the mayflies were a bit more variable and weren't as significant as the caddisfly results. But what it shows is that there's a big decline in the number of these insects in the Netherlands. Here in the UK, we're seeing similar sort of patterns. We've already lost the mayflies, Arthroplea congenia, which you see here, and Heptogenia longicauda. They're both considered extinct. There are 2 stoneflies that are considered extinct now, Xanthoperla apicalis and Isoperla obscura. And we may be witnessing the UK extinction of the caddisfly, Glossosoma intermedium. It's not been seen for 20, 25 years, and it seems to be on its way out. It's only been found in very high altitude streams, so it may be a victim of climate change. Coming back to the UK and looking at the data we have in the UK, our main source of information is the State of Nature report. However, most of the freshwater information in the State of Nature report is based on birds. Not much to go on with invertebrates, but this occupancy indicator, which is about where the species, how the distribution of these species has changed rather than the abundance of the species, shows interesting distribution of results. So basically, it shows a massive decline during the 1970s and 1980s. And as Steve mentioned there, there's lots of different reasons for that. But what's interesting is the recovery after that and during the 1990s and early 2000s. And that's probably the result of the introduction of the Urban Wastewater Treatment Directive and the improvements in sewage treatment. You notice that it doesn't go back to the 100. It's not quite back to the levels before the 1970s, but it shows a recovery. But what does this really tell us? I mean, it says that resilient species have bounced back after chronic pollution over many, many years. But what about the rare species? How are they faring? Well, they've probably been lost in that initial pollution incident, pollution episodes. So looking at the trend of data for 359 freshwater invertebrate species, we can see that in the short term on the right-hand bar chart at the bottom, we can see that for freshwater invertebrates, there's some 52% of them are in decline, while in the long term, 58% are in decline. So there's still declines happening, just that it's balanced out, it's relatively well balanced out with improvements. Breaking that down further, we can see that of the groups of freshwater invertebrates that there's data for, we can see that mayflies and aquatic bugs are faring particularly badly, with 54% and 53% declines. But on balance, dragonflies are doing better. And that's probably not surprising considering their mobility and their ability to move to other locations, other habitats. But what this shows is that there are winners and losers. It's not just a case of, you know, things are getting worse. Some species are actually recovering well, others are declining. And generally speaking, it's the generalist species such as the large dark olive and cinnamon sedge that have increased, and the rarer, more specialist species that are in decline. So that's the background to insect declines, but moving on to flea treatments and pesticides. Buglife's been concerned with pesticides in freshwaters over the past decade, maybe 2 decades. One of our very first campaigns as an organisation was to ban the use of cypermethrin in sheep dips, which was successful, with their use banned in 2005, their sale banned in 2005, their use banned by 2010. And since then, our efforts have concentrated on neonicotinoids, with our report on the impact of these pesticides being published in 2009. So one of the first sort of like markers that there was a problem here for pollinators in that case. And over the next decade, we campaigned for a ban on these damaging substances because of their effects on invertebrates. And a particular focus was their impact on freshwaters, which we reported on using data collected by the agencies. This was data that was collected as part of the EU watch list process, so that the European Union were looking at which substances should perhaps become the next ones to be monitored. So there was a monitoring process just to see what the levels were across the EU. And the data that was collected in 2016 for the watch list by each of the agencies in the UK showed that over 85% of the monitored watercourses were contaminated with neonicotinoids. 7% of all the samples from England had concentrations above the acute toxicity level. So that's the level where it could cause lethal effects. Imidacloprid, one of these neonicotinoids, was even found in a control site in a remote stream in the Highlands of Scotland, where pesticides were unlikely to be present. And that started us thinking a bit about where these pesticides were coming from. So historically, the obvious source was on seed dressings, on oilseed rape, or spray-on products that were sprayed onto crops. However, in 2013, there was a ban on the use of these neonicotinoids in flowering crops in Europe, which meant that that source was not as important now. So there must have been another source for these pesticides in recent years. Interestingly, the government has now allowed the use of neonicotinoids, and they've given a derogation to allow the use of neonicotinoids on sugar beet, although that derogation hasn't been used because the conditions haven't been right yet. But again, they've authorised it for this year. So if there's a outbreak of a particular pest, farmers may use it again in a widespread use. So our attention turned to what other places imidacloprid was used, and the discovery of the imidacloprid at the control site on the Altan Dúloch in Scotland, which was miles from any agricultural or forestry uses of neonicotinoids, made us look closely at whether it could be something to do with recreational activity in the area. It's very popular. The area is very popular with hill walkers and recreational walkers, dog walkers and the like, and the possibility of imidacloprid entering the water after a dog treated with a flea treatment containing that chemical had swum in the river or urinated in the river was one that we looked at. Now these flea treatments are widely used. Nearly 9 million dogs and over 11 million cats in the UK, and it's thought that about 79% of these companion animals are treated to prevent fleas. And it's a prophylactic use. It's not because the dogs and cats have fleas, it's because they might get fleas. And typically speaking, you know, if you can do without these chemicals. The chemicals typically used are imidacloprid and fipronil, and these treatments are designed to have long-lasting effects. These images from a paper show that they put a fluorescent marker into the treatment and then applied it to a dog. You can see that after 24 hours, it's spread across the dog. The effects actually went on for up to 4 weeks. They were still picking up traces of it on the bedding and the gloves that they'd given the owners. And you can see that it's transferred also onto the owner's hands. It will transfer onto the owner's clothing and so on, and furnishings and things. They're systemic, so they enter the bloodstream and are excreted in the urine. And like I say, they also contaminate the bedding and their owners. So if bedding is washed, it can wash off into the wastewater. Steve mentioned Rose Perkins, and Rose actually volunteered with us before she started her PhD at the University of Sussex. But she was looking at investigating the prevalence of these substances in rivers. And whilst imidacloprid may be used in other circumstances, it's licensed for a whole range of different uses. Fipronil is only used almost exclusively for flea treatments in companion animals. So fipronil is a really good indicator of where flea treatments are having an effect. Given the things that Steve said at the end and that question that you may get materials coming across from other countries, but generally speaking, fipronil in this country is only found in flea treatments. So again, monitoring data from the EEA was investigated, the Environment Agency was investigated, and what Rose found was that there were high concentrations of imidacloprid and fipronil present downstream of wastewater treatment works. So these graphs, the left-hand bar box chart on each graph is within 2 kilometers of a wastewater treatment works, and the right-hand bars are greater than 2 kilometers. So you can see in the top row there, the fipronil and fipronil sulfone, which are much higher concentrations closer to wastewater treatment works, and the same in the bottom graphs there, particularly on the bottom right, where you can see imidacloprid, far greater concentrations closer to sewage treatment works. And this is what we expected to see with washing of beds and bedding and things, and the prevalence of dogs and cats in urban areas. Looking across Scotland, Rose also looked across not Scotland, England, and almost all rivers with data exceeded the chronic toxicity levels, and many also exceeded the acute toxicity levels. The chronic levels are where sublethal effects might happen, like that might affect the behavior of the invertebrate or the reproduction or something that doesn't kill them outright, but affects their population community makeup. And then the acute levels is where there may be lethal effects. And you can see here there's a number of sites that are above that red dotted line, which are the acute levels. Looking at that across the country, this is more graphical form of those results. You can see that these substances were found, fipronil was found in all the rivers that were investigated, with almost all rivers having concentrations of fipronil sulfone that exceeded the acute toxicity limit. So it looked like a very widespread problem with potentially quite serious implications. So that's all done with chemical monitoring. If we want to take this back to the riverflies, take it back to the invertebrates, and what effects does it have on invertebrates? We can use a scoring system called the Species at Risk, SPEAR scores index, and this looks at the effects whether a substance is whether a species is sensitive to a substance or tolerant of that substance. So we can use the different sensitivities of the invertebrate species to determine the effect that pesticide might be having on their populations. And the Species at Risk Index, which is more commonly known as the SPEAR Index, categorizes invertebrates based on a series of traits such as generation time, dispersal capacity, etc. And it splits the invertebrates into tolerant and sensitive groups. You can then calculate the score based on the invertebrates that you find in your sample. So you take your monitoring data like this, you then link it to the sensitivities database that is available. And that you can see here, the beta there are scoring 1 because they are sensitive. The rest of the things on the screen there are tolerant. And then you can calculate a score for the site. And the score has a sort of like breakdown of an interpretation there of from high to good to bad. And you can do that across samples across the country. So we took the Environment Agency's monitoring data and applied this method to it and had a look at what the SPEAR score was across England, and the results were fairly shocking. This graphic was prepared using that EEA monitoring data, which was run through the SPEAR calculator to obtain SPEAR scores. The data was then matched to river subcatchments to show the spread of the potential effects across England. You can see widespread red and orange colouring indicating potential effects from pesticides. And then looking at, and you can see that in the areas where perhaps there's less people, in Cumbria and in the Welsh Marches and the southwest, there's less effects. Another interesting thing we were able to look at was to look at the results in more detail in terms of what size of river was more affected. And it appears that smaller watercourses, those with lower discharge categories in this graph, are more likely to be affected than larger watercourses. And that's probably not surprising because larger rivers have more water to dilute the pesticide contamination that's there. So just to finish off, some conclusions. Well, fipronil is present in watercourses across England, and most watercourses that have been looked at have got some form of that have been monitored for it have got fipronil in it. The likely source is pet cat flea treatments, because we've seen it downstream of sewage treatment works. It's the only real source of fipronil in this country. We can use invertebrate monitoring to identify pesticide effects. And when we do that, we can see evidence of widespread pesticide contamination. So Buglife's recommendations that we've been promoting and advocating for are a ban on the use of fipronil and imidacloprid as flea treatments, and a better risk assessment of other insecticides that are applied to companion animals. And then finally, a better regulation of flea treatments in general. You can buy flea treatments over the counter. You don't need to get them prescribed from your vet. But there's no understanding of just how much of that is, how it is being used, or how it's being used. It needs better regulation. Thank you for listening, and I'm happy to take some questions.
Thank you, Craig. That was absolutely excellent. So perhaps Steve could join us back again. That would be fantastic. So we've had two excellent presentations on emerging science and scientific challenges. And there's some questions here. I've seen Steve has been trying to answer a few questions in the chat as we've been going along. There's one question here for you again, Steve. You commented that ecological recovery of rivers is slowing down. Do you have a hunch why that is?
Well, we're clearly following the lines of investigating other sources of contamination, and that's what the pharmaceutical bit of the talk I think was about. I don't think we have enough data to absolutely nail the reason. And one other thing to be aware of is the kind of developing climate change effect also. So Ian Vaughan, my colleague in Cardiff, published some data in Nature actually about 2 or 3 years ago, illustrating that cleaning up organic pollution had helped to offset some of the developing warming in river environments. But it was only a matter of time, he thought, before climate change effects would start to bite. So warming rivers have less oxygen, and the kinds of organisms that are potentially at risk are also the ones that are at risk from organic pollution. So, you know, I think with several hypotheses that we haven't absolutely nailed down. Craig, I'm really interested in SPEAR and what that can tell us about different kinds of contaminants. And I'd be really interested in how unique the responses are by organisms to different chemicals alone and in combination. Because I think that, you know, that is something else I think we've got to open up in quite a bit more detail.
Yeah, SPEAR can be adapted, Steve, to if you've got the information to feed into it, you can adapt it to whatever chemical you want. So if you know the likely effects and the likely exposure, then you can build SPEAR analyses for that. So I think there's ones for salinity and things already. But yeah, that would be something that you could do. And it's crossed my mind that it would be good to do something on pharmaceuticals.
Another quick question for you, Craig. What do you make of the ChemPop study that is saying the opposite, that EPT diversity and freshwater abundance is improving?
I still stick with what I said in my presentation, that it certainly is improving, but it's not necessarily not everything is improving. So there's the studies that were done by Charlie Outhwaite that showed changes in occupancy of species showed that there were clear winners and losers. So some of the stoneflies were clearly still struggling, whereas there was others that were doing much better and were increasing in numbers and masking out that sort of like those struggling species.
Great, thanks for that. Reluctantly, we have to press on. We're running a little bit behind time, but Steve and Craig, I think there are a few more questions in there from Bill and one or two others. Perhaps you could try and answer those during the rest of the time we have. If not, we can follow up. But both, thank you very much for those great presentations. Our next speaker is Rick Batterby. Rick is from University College London and another FBA fellow. And the title of Rick's presentation is Working Together on the Wharf, the Role of Citizen Science in the Quest to Clean Up the River. Over to you, Rick.
Right. Thanks very much, Simon. And thanks to, can you hear me all right? Yeah. And yeah, thanks to Steve for the invitation. I've called it actually Worrying About the Wharf. I forgot what the title was that I'd submitted, but it's the same content anyhow.
I'm just waiting for it.
And
hang on.
Just going to go to full screen.
Yeah, I'm just waiting. I'm waiting for this to clear. Should go away. Oh, come on. Yeah, it's behind there.
Can you see the slides okay?
Well, no, they can't. No, they can't yet. We need to go.
Stop sharing.
Rick, maybe if you click on slideshow.
Sorry?
Click on slideshow to the right of animations.
Hidden behind a bar.
It's hidden behind a toolbar at the top of our screen, which we can't remove.
I think it's there. There we go. Found it. There you go.
How about that?
You're in business, Rick.
We're in business. Oh, that's great. Okay, can we move this as well there? So I wanted to talk about the work we've been doing on the wharf, and this is just an introductory map, as you can see. So the wharf is one of the rivers in the Pennine Yorkshire Dales National Park, or the top part of it's in the national park. It runs down from high elevation in the national park down and to near York, where it joins the River Ouse. And I wanted to talk about projects that started about 3 years ago is centered around Ilkley. There's Ilkley. It's about halfway down the river wharf system. And then sites that we've looked at upstream and downstream of Ilkley. And then gradually we then moved to look at the whole catchment. And so it started really with looking at one of Ilkley's great visitor attractions, the sewage works there, as you can see on the river wharf, with concerns about untreated sewage being discharged into the river via the storm overflow. Particularly interesting because the two popular parts of the river in Ilkley are, as you can see there, the Cromwell Beach, which is fortunately just upstream of the sewage works, and then the Beanans Island Beach, which is unfortunately downstream of the sewage works. And the concern was to do with these spills from the untreated effluent. Interestingly, at the time, and still even today, in fact, not so much attention was paid towards the treated effluent outfall. And one of the points I want to make and demonstrate towards the end of the talk, in fact, is that the treated effluent is just as important as the untreated in needing attention to improve the quality of rivers there. So this is what the storm overflow looks like. This is in March 2016, a discharge of organic polluted effluent, but also containing high concentrations of fecal bacteria and nutrients, of course. And the concern at this stage was mainly about fecal bacteria. And here, just a little bit downstream, about 50 to 100 meters downstream, is what looks like beautifully treated water, crystal clear water. It has very low concentrations of organic matter, so that's fine. But it still has high concentrations of fecal bacteria and nutrients. When we started with this concern about the untreated sewage, the first thought was we need to contact the Environment Agency and get some numbers on fecal bacteria concentrations, but soon found out, of course, that the Environment Agency had got no responsibility for monitoring concentrations of fecal bacteria in rivers unless or at any site unless they were designated as bathing water sites. So we started a citizen science project, starting off by this need to monitor fecal bacteria, identify sources of pollution, and needed to raise some funds. And we were fortunate enough to find some funds from Ilkley Town Council, from the local Wharfdale Naturalist Society. And if Michelle's still on the call, to say thanks to Michelle, because the Rivers Trust gave us some money to get started as well. We started off with some local angler friends, two Steves here, Steve Cheetham, Steve Fairbairn, and we took our first sample, as you can see on the right there, in April 2019. And this is the Ilkley again, and you can see the sewage works in the middle, and we were sampling upstream and downstream. And the first set of samples were in June 2019, and this was during a storm event, so we had high flow. And what was very striking was that we got high concentrations of fecal bacteria at every sampling point. So if you can see where we are in the sewage works in the middle there, point 1 is the storm outflow, point 2 is a treated effluent. Very high numbers there. Think about 1,000 as being a kind of level which might be safe enough to swim. So there we are, 32,000, 43,000 around the sewage works. But interestingly, even upstream of the sewage works, we were getting numbers of 11 to 12,000 CFUs per 100 mil. A month later, we have very low flow condition. You can see a dramatic difference in the numbers, showing this dependence on concentration dependence on flow. But interestingly here, we've got those low numbers upstream, 100, 450, 350. Clearly there was no spill of storm sewage at that point. So between the overflow and the treated effluent got very low numbers indeed. But downstream of the treated effluent, we have 2 orders of magnitude higher concentrations, 35,000 there. And that was the first time that we realized, and everyone else realized, that in fact it's not just the untreated, it's the treated that is actually discharging high concentrations of fecal bacteria. there we can see that number there. And so here are the two beaches. The downstream one, we could then argue that anybody using the beach downstream is at risk in any condition, because even in lovely warm summer days when there's no storm overflow, there's still a high risk of exposure to the treated effluent that's running continuously. And then upstream again, although conditions look fairly good in dry weather, we could see from that high flow set of sampling that the high concentrations are also possible there. Now, this time we were concerned about raising awareness about the problem, and the idea was that we should apply for bathing water status. Unfortunately, in fact, bathing water status is based upon the visitor popularity of the site. You could see from the previous two slides, not on the water quality. And so in December 2020, DEFRA awarded bathing water status to this stretch of the wharf on Ilkley, the first of its kind in England. But once that bathing water status was allocated and the sampling point was selected upstream of the sewage works at what we call the Cromwell Corner, the question then was, would this site ever pass the threshold for safety? What were the sources of fecal bacteria coming down into Ilkley? And at this point, it was a concern about not just sewage works upstream, because there were very few with just small villages, but about the possibility that some of the fecal bacteria could be coming from agriculture. And that's to some extent where the debate is at the present time, the extent to which the bathing water site is contaminated by Yorkshire Water sewage assets or by agricultural sources, especially cows, because that's a real concern as well. And I'm not going to go into the details here because there's a whole lot of data, citizen science sampling of fecal bacteria concentrations upstream to try to tease those sources apart. But just to show a couple of pictures, this is where we live, in fact. This is the stuff that comes from Addingham village homes. It's a pumping station in our village, and you can see in wet weather there's a spill. It doesn't look very nice. It actually spills into a local mill stream, not directly into the river, and so it doesn't really get diluted at all. So that's a source of high concentrations of fecal bacteria coming down in wet weather conditions. But there's also, as I mentioned, lots of agriculture upstream, and here's a picture of cows just drinking, but also evacuating, one might say, into the water upstream at Bolton Abbey, just to illustrate the importance of looking at agricultural sources as well as CSO sources to explain the high concentrations there. So at that point, we were thinking about this ability to separate fecal bacteria from humans and ruminants, and we're pursuing that essentially using molecular techniques, and the project we have running with Sheffield University, looking at the DNA of bacterial samples. That's a talk not by me, but someone else, in fact, for another day. But going back to the fecal bacteria in the rest of the wharf, the question then, to what extent were we seeing the kinds of numbers around Ilkley? Could we see them further upstream or even downstream, in fact, where there were towns and villages discharging into the river? The other question, of course, and many people were confusing these two issues, the question of the extent to which the kinds of pollution we were seeing in the river was of real concern for the ecological health of the river. So fecal bacteria, clearly a problem for human health. What about the ecological health of the river? We need to start to look for different kinds of evidence. What kind of methods should we use? To what extent can we look at the whole river using a citizen science approach? And having learned how variable the fecal bacteria concentrations were with respect to flow, how could we sample the whole river, in fact, under similar flow conditions? And this lends itself to a citizen science approach. What we did, we looked at the whole river, as you can see here, from the Dales down to near York, divided the river into 5 zones, different colors there on the right hand side there, and we had teams of 5 people. Each sampled 12 sites, starting upstream and moving downstream, and we managed to sample 60 samples of the river, covering that 125 kilometers of the river, and we did that in 4 hours in the morning of Monday, the 24th of August 2020. And as well as looking for fecal bacteria to look at the variation in fecal bacteria concentrations, we then started to look at nutrient chemistry and diatoms and riverfly to look for ecological impacts. Thanks. Issue was, how can we do this in where the water levels are more or less the same along the whole river, as I say, by using citizen scientists over that short period of time. We were hoping, as you can see on the left, that's 22 days in August, to be able to do it in low flow conditions, and we had lovely low flow conditions for the first half of the month. But then just before we were due to do our sampling, you can see a whole succession of rainfall events coming through there. The arrow shows the 24th of August when we did the sampling. On the right hand side, that's just spread out, it's 6 days there, and the little red bar there is the 4 hours that we were sampling. But you can see from these river level sites that are situated along the full length of the river that we managed to sample pretty much in similar conditions on that day. We used a standard weighted drop bottle, either from bridges or by thrown in from the side, or if we couldn't wade into the site. And because it was fairly high flow on that particular day, we had to use a drop bottle or a throw bottle to get the samples. The biology we could follow up, I sampled the diatoms then over the next few weeks, working slowly down all the way from the top to the bottom to get diatom samples at every site we had water chemistry for. And the idea was to do the same with riverfly. Here, the bacterial concentrations along the river, you can see the spike in the middle, there's Ilkley standing out as being the main source of fecal bacteria. And you can see downstream from Ilkley as the river goes through Otley and Wetherby and Tadcaster, high concentrations all the way down to the River Ouse. But what was surprising was that upstream also in Upper Wharfdale, we got high concentrations as well. Some of those associated with village sewage assets, but quite a lot of that must be related to agricultural runoff on this particular high flow occasion. Again, I don't want to dwell on that because I want to focus essentially on the ecology. And on that same day, as well as samples of fecal bacteria, we had samples for nutrient chemistry. They were done by CEH lab in Lancaster. And one amazing thing was that by sampling so synoptically, as we might say, a snapshot sample all on the same day along the river length, we get beautifully coherent chemistry. And you can see on the, you won't be able to see the sites there, but I put the line through for Ilkley, that the pH, the alkalinity, dissolved oxygen all the way down through the river. But the standout there is the phosphate, phosphorus, the orthophosphate concentrations there, very, very low levels, below the levels of detection in the upper part of the river. And it's only when we hit the sewage works in Ilkley do we see that spike. It's an outlier spike, and that's, I think, because that particular sample was taken in the plume down from the treated effluent, and the effluent hadn't mixed fully into the water. But then you can see following down that phosphate down the river, it increases and then stabilizes round about that 20 micrograms per litre mark. So very, very clear changes in the nutrient concentrations down through the system with that main breakpoint in Ilkley. The diatoms were then analysed from each of these sites, and you can see the same sets of sites and the diatoms on the left. I don't need to go into the individual species, but you can see very clearly, if I put that line through it there, that here again we've got Ilkley, and that's the point at which we have the major change in the diatom composition. The Acnanthe species there declining quite rapidly, and then a range of new species coming into the river at that point. diatoms that we actually associate with poorer quality conditions, especially motile forms of those diatoms. But quite interestingly, what the diatom data showed that snapshot chemistry didn't was that there's also a change in water quality indicated by the diatoms further upstream in Grassington there, particularly by the occurrence of that Nitsia palea species there. So beginning to get some real interesting information. Riverfly we hoped would actually follow on the diatom, but one of the problems was that we had too few people able to go out, and we only managed to get 18 samples or so. As you can see, there's some major gaps then downstream shown by the circles on the right-hand side. Upstream, we had some really high quality conditions, as you can see there. Interestingly, though, that there's very little change in the invertebrates between upstream and downstream of the sewage works. And that was something of a surprise to us there. And sadly, we didn't have the samples further downstream to explore that further. So following on from that, we were interested in going back to the diatoms, the extent to which there's a continuing deterioration downstream from Ilkley, and the question about whether it was the intermittent discharge that was causing problems for the diatoms or the continuous discharge of treated effluent, or both. And then exploring this question about why the riverfly assemblage didn't seem to change upstream and downstream of the sewage works. So just a new project from last year with chemistry, diatoms, fecal bacteria, filamentous algae that we haven't made much progress in at the moment, and macroinvertebrates. And instead of using riverfly, we use a commercial lab APEM to do a species-based look at the invertebrates along the samples. And the difference on this occasion was that we introduced a sample 6, as you can see in the middle, between the continuous outflow at 0.7 and the storm outflow at 0.5. And interestingly, these are the data, the 10 sites there in sequence on the left-hand side, looking at the diatoms, almost identical results to the 2020 sampling, with that change in diatom composition at just before the Beanlands Island sample there. And the same results for the phosphorus at the bottom there, with below detection limit levels until we hit the sewage works. But the interesting thing here is that we don't see a diatom response downstream of the CSO. We only see the diatom response downstream of the treated effluent. And you can see that on the map on the right-hand side. So it's a treated effluent. It's a continuous discharge of nutrients from the treated effluent that are causing the ecological problems, not the intermittent discharges from the storm effluent there. And this time, of course, the macroinvertebrate data were good because we had species-based counts. And what I've done here, I've put them into groups and made percentages. And again, we can see that there was very little difference between the assemblage upstream and downstream of the sewer, of the combined sewer overflow, the storm overflow, and no difference between the treated effluent and the next sample down. Again, suggesting that the diatoms were showing a change, but not the invertebrates. But as we go further down, and as the river passes and receives discharges from different sewage works and CSOs, we do see some deterioration in water quality indicated by the invertebrates. And you can see the decline in the heptagenid mayflies. There seems to be an increase in mollusks and an increase in case caddis, and that's reflected by just slight decreases in the WHPT scores there. And so to summarize, this is what we think we have down the river across the Ilkley stretch. High conditions upstream despite CSO coming in from Addingham and upstream from Ilkley. But then from the Ilkley discharge through 0.7, 8, 9, 10, as the river receives more and more nutrient-rich and organic-rich discharges from both CSOs and sewage treatment works, we have this gentle deterioration in water quality. So just to sum up in a few key points there, I think the data shows that we have nutrient pollution as far upstream as Grassington, but the main deterioration starts in Ilkley. And it's the key point here, it's the final effluent, not the storm overflow, that's the main source of pollution. That's clear from the diatom data, but not from the invert data at that particular point. But we think the invert data and the diatom data together indicates this continuous deterioration downstream. And we can see that the Riverfly is not really picking up so strongly that that decrease in water quality. And in this particular setting, I would probably argue that the Riverfly are poor indicators of the nutrient pollution. So picking up from this morning, it seems to me that maybe this is something that would be picked up by the extended scheme, but it's not picked up by the standard Riverfly scheme. And then just a couple of final points is it's the good demonstration, I think, of the really important need to have co-location between chemistry and biology, and really interesting how good the results are when we carry out what I call synoptic sampling or snapshot sampling, essential for doing chemistry and bacteria, and that does need citizen science. So thanks to the citizen scientists and thanks to our project funders. And that's not part of the show. Thank you.
Thank you so much, Rick. That was absolutely brilliant. Really, really inspiring. Judging by the reactions I can see on the screen already, everyone's thoroughly enjoyed that. If I may, Rick, could we defer questions to the end of the session? Because obviously Kate's presentation, I think is very complimentary to yours, so we might be able to fuse some questions together. So thank you, Rick. So the next presentation is from Kate Heppel of Queen Mary University of London and the Children's Chalkstream Project. And the title of Kate's talk is Citizen Science and the River Chess Smarter Water Catchment Programme. Over to you, Kate.
Thank you very much. Let's get the slides started. Can you see the slideshow okay?
Yes, yeah, we
Brilliant.
can.
Okay, lovely. So I'm here to talk about citizen science and the River Chess, but I'm really representing the work that's been done by lots of key partners on the Chess Smarter Water Catchment Programme, and of course the work of our citizen scientists, and some of those have been working on the River Chess for over 10 years now, taking Riverfly samples. And the Chess Smarter Water Catchments project is very much a collaboration between the water companies, the local rivers groups, the local authority, environment agency. You can see the kind of partner logos here. In terms of what is the Smarter Water Catchments Initiative, and I think Joe Pecorelli touched on this earlier on for the Crane, it's a Thames Water pilot project at the moment, looking at the environment as a system and working in close partnership to try and co-create and co-deliver solutions to the threats to river health. And the River Chess is one of those rivers. The River Chess is to the northwest of London. It's in the Chilterns area. It flows through Buckinghamshire and Hertfordshire from an urban source of Chesham through down to Rickmansworth and out to the River Colne. Now, the idea of the project is to get partners working together, and the partners thought up the 10-year co-designed plan for the River Chess, and the plan aims to restore the health of the River Chess. So there's an online plan that you can look at, and we've embedded citizen science activities within this plan. And I'm going to tell you a little bit about how the plan has kind of developed, but also going to look at some Riverfly data as well that's arisen from the project and how what we're starting to interpret. So in terms of the different themes in the Chess Smarter Water Catchments plan, one of the themes that we're looking at is improving water quality. There's a theme looking at managing flow, controlling invasive non-native species, improving wildlife corridors, and then there are a couple of themes about working together, involving different partners and also involving the public and citizen science activities as well. And one of the first parts of the project was to do a baseline assessment to identify all the different issues in the river. And I just wanted to run you through some of those. We basically did a knowledge gap analysis. We pulled together all the data on the river with relation to water quality from the Environment Agency, from any studies that have been done in the past, and asked ourselves, well, what isn't known about the river? What knowledge don't we have, and what gaps do we need to fill? And which of those gaps can be filled via citizen science? So on the water quality side, what we realised was we wanted to understand a lot more about the frequency and the duration of storm tank overflows and the effects of those storm tank overflows on river health. So that was one aspect for water quality. And then we wanted to look at the extent and effect of fine sediment on the river. We've got urban areas at the river source and agricultural activity in the catchment, together contributing fine sediment to this chalk stream. And we wanted to understand where is most of the sediment coming from, which different activities, and again, what is the effect here on river health? The other issue we had was that of high phosphate concentrations in the river. So 96% of the phosphate comes from sewage treatment works, and that's being tackled at the moment through the current WINEP programme. There's phosphorus stripping going in on the treatment works to lower the concentrations by the end of 2024. But there's also an increase in the lower reaches of the river in phosphate, and we don't really know why. So phosphate's important to us as well. And the other thing we wanted to do on the water quality side was horizon scanning to understand the emerging contaminants in the river, their potential sources, and what can be done about them. On the managing flows side, here we wanted to understand the effect of groundwater abstraction on river flows, and to understand as abstractions are reduced in this system, then what does that mean for the effects on river health as well? Under the improving wildlife corridors theme, we wanted to understand what are the benefits of the river restoration projects we're putting in? Are we really achieving our aims for these projects? And what could we do better? How could we improve our management practice? And all of these we thought could be tackled to some extent by citizen science activities. So I'm just going to tell you a little bit about some of those activities that we've used to try and address these critical questions. Now with chalk streams, we view the river health to be due to a combination of three critical things. We need healthy flows in the river. We need good water quality, clean water, and we also need good habitat. So we wanted to ensure that our citizen science activities covered those three aspects of river health. So what we did then was choose a combination of different citizen science toolkits. So some that are already out there that essentially we're using, so what I would call supported activities. And then in other ways, we've identified gaps where we wanted to create our own particular citizen science program. So we've kind of blended our activities together. We've got really long-standing invertebrate monitoring on the River Chess through the Army Riverfly programme. So as I said, over 10 years of 12 sites along the River Chess. But we wanted to augment that with a technique that offered us to an insight into the actual pressures on the invertebrates. You know, were the pressures from flow, from low flow, were the pressures from fine sediment, from phosphorus, or indeed from pesticides? And Smart Rivers offered us the opportunity to do that. So we've combined our Riverfly and Smart Rivers as well. So I'll tell you a little bit about those later on. We also wanted to understand the water quality and in real time. So we wanted to be able to respond, for example, to storm tank overflow events to understand what was happening in the river system. So for that, we've put in real-time monitoring through a series of 6 sensors in the river. And then we identified modular river survey as the technique we wanted to use to look at habitat and to identify before and after restoration projects that we're putting in along the river. Now there's a real emphasis on fine sediment because this is a chalk stream, and we needed a technique to be able to say, well, what's fine sediments coming into the river and where? And how do we prioritise which fine sediment issues we tackle first? And Mud Spotter gives us the opportunity to look at the locations of fine sediment input to the river, the timings of the fine sediment inputs, and the extent. And with MudSpotter, we're also finding that we can just walk along the river and add photographs of interesting features along the river as well, because we're essentially putting the data straight into an online GIS system. It's run by cartographer, and we're able to use that then not just to track mud, but also to track interesting events in the river that are then time-stamped for us. Now, the horizon scanning that I mentioned earlier on, it's really important for us to understand what the future chemical issues might be on the river as well. So we're working with Imperial College to look at emerging contaminants. Our citizen scientists take samples every month, and we're looking there at chemicals that are outside the current regulatory process. We want to combine this understanding with water quality with flow, because the flow, and I'll show you an example later on, flow has a really important impact on our chemicals. So on the concentration of the chemicals in our river, because it's a groundwater fed system. So where we do flow monitoring, we want to also be able to do chemical monitoring and understand the stresses on the invertebrates as well through doing also invertebrate monitoring. So having sites where we have all three of these is really important to us. And finally, we kind of created our own little survey technique, which we're trialing actually next week, called NOSES, for our nutrient monitoring, and specifically to be looking at phosphate and nitrate concentrations through the river. So if you look at these techniques in relation to sort of healthy flows, water quality, and good habitat, the emerging contaminants analysis, where we just go and collect samples and send them off for analysis for the emerging contaminants, is looking at some of the water quality aspects. We've got chest watch sensors looking at water quality, NOSES for our nutrient analysis, MudSpotter for sediment. We can then use MudSpotter as well to combine with habitat. So MudSpotter is telling us where fine sediment might be coming in and smothering the riverbed. And that goes hand in hand with our MORPH, our modular river survey analysis, to look at habitats as well. And so then we've got the Riverfly and smart rivers that kind of sits at the middle of this Venn diagram here, because this is allowing us to look at the stresses on the invertebrates in the river system. And then flow monitoring is another important aspect of our activities. So what I'm going to do now is just take you through some of the Riverfly data that we have and the smart rivers data, just to tell you how we're using this data to start to piece together the stresses on the River Chess. So first of all, I'm just going to focus on some Riverfly data we've got from ephemeral reaches of the Chess. So we have 2 Riverfly sites, and these are sites where 2 of our really dedicated Riverfly volunteers have been doing sampling for over 10 years now. And so we've got a really lovely long-term record of the invertebrates in this section. So this is a section of the chalk stream that is sometimes dry and is sometimes wet. It's upstream of the main sewage treatment works on the River Chess, which is downstream of Chesham. And this area also receives runoff from roads and from agriculture as well. So just to give you an idea of what these sites look like, at the top here we have the site when it's wet, the chalk stream site when it's wet, and on the right here when it's dry. And then we have the lower site within Chesham, which is in a place called Meads Water Gardens, again on the left when it's wet, and on the right when it dries up. So this is a section of the river that would naturally dry. At times it's a winter-borne section of the River Chess. And as I said, we've got this long-term record from here. So this record runs from 2011 to 2021. We're lucky to have a stage board run by the Environment Agency near both of these sites. So we've downloaded the data from that stage board, and you can see here then the water level in the River Chess rising and falling over the years, and doing so in response to the groundwater. So this is a groundwater fed stream. So when the stage or the river level is high, that's because the groundwater levels are high. And when it's low, or where there's no water in the stream, that's because your groundwater levels are low. So on this panel, you can see red areas. This is where our Riverfly volunteers have noted that there was no flow. And the blue areas are where we were using the stage board data to infer that there's no flow. So one thing that we realized was important as we started to go back through this data was this extra functionality when you enter the records in to say whether you don't go to the sampling site or whether when you got to the sampling site there was no flow, and having that consistently recorded over the years is really important. So it's actually great to see that that functionality is being included in Cartographer. I think that's really important for ephemeral stretches of rivers. What we've learned from looking at this data over time is a bit about the recovery time. So this is the ARMY scores for the Queen's Head sites, the sort of site furthest upstream, and the Meads Water Garden sites, which is the second site, both ephemeral. And you can see that during the periods of no flow, obviously we have no ARMY score data, but then we can see recovery of ARMY scores in between time when we do have flow in the river system. And we can see recovery that can take 1.5 to 2 years of continuous flow in the river for these aquatic species. We'd love to combine this with dry phase sampling to really fully appreciate the invertebrate life that's associated with winterbournes. So I think one of the sort of requests from us is, could we start to think about invertebrate sampling in dry riverbeds as well as in running water as well, to really understand what's happening in terms of these chalk streams. That would be a really nice addition to these types of methodologies. I'm going to move now to the perennial reaches of the Chess. As I said earlier, we have 6 sensors that are sending us data in real time over telemetry. And these sensors measure lots of different water characteristics, but I'm just going to talk about dissolved oxygen for the first example here. We put these sensors into the river back in 2019, and they give us data every 15 minutes. So we've got quite a rich data set now from the River Chess. And the sensors were put in conjunction with the River Chess Association, and asking the group where did they want the sensors in the river and why. And as I said, one of the first things that we all wanted to tackle was the issue of storm tank overflows in the river. When were they occurring? And how frequently. So this yellow square here is Chesham Sewage Treatment Works, and one of the first things we did was bracket the sewage treatment works with a sensor upstream and a sensor downstream to try and understand what was happening in terms of the frequency of storm tank overflows. So here we have the top panel is 15-minute rainfall data. This is from July 2019 to September 2021. The peach areas here on this plot are the periods of time during which the storm tanks were overflowing from Chesham Sewage Treatment Works. So you can see there are some very thin lines here and some longer periods of storm tank overflows. So the thin peach lines tend to be when there's been heavy rain and the capacity of the sewage treatment works to deal with that rain is exceeded, and then the storm tanks operate. Essentially, they overflow and untreated effluent goes into the river system. What's happening here for the longer time periods is that the groundwater levels are high. So you can see here that in the lower plot, you can see the river levels are high, and that's because groundwater is high. And that groundwater is actually entering the sewage network in Chesham. So that sewer network in Chesham is actually perforated. It's been perforated by various building activities over the years that have literally cut holes into the sewer network. And when the groundwater rises, it enters into that sewer network, travels to the sewage treatment works and overwhelms its capacity to treat the water. So we're getting too high a volume of water moving through the sewer network in too short a space of time. So back in 2020, for example, when groundwater levels rose, we had about 2 to 3 months of continuous untreated effluent going into the River Chess. And that repeated again in 2021, when again we had similarly high groundwater levels. So we were able to track what this meant for dissolved oxygen. So this plot here is showing you the dissolved oxygen percentage saturation. And again, the peach areas show you when the storm tanks at Chesham Sewage Treatment Works were overflowing. The green dotted line is good dissolved oxygen levels. Orange is moderate, and then the red is poor here. So we could then see that our periods of storm tank overflow were having effects on the dissolved oxygen levels in the river downstream of Chesham Sewage Treatment Works, and for prolonged periods as well. The reason why the line is so banded is because dissolved oxygen levels change on a daily basis. So during the day, when you have photosynthesis, oxygen is being created. So oxygen levels are higher than they are at night. At night, the photosynthesis isn't occurring, you've got respiration, so you get your lower oxygen levels then. So you can also see that during the 2020, that amplitude of daily oxygen changes really broadened out as well, because we had a lot of photosynthesis due to algal blooms at that time. In 2021, you can see that there was a period of quite low oxygen. So this has been really interesting to sort of demonstrate the effect that these storm tank overflows are actually having on the river system in terms of the water quality. As Rick mentioned earlier on, there isn't regular fecal bacterial monitoring of rivers unless they're designated bathing waters. So we don't really know the levels of bacteria and viruses in the water at these times due to the storm tank discharges. And that's something we want to investigate into the future if this kind of things continues to happen. But what we did have was our Riverfly data to try and start to tease out what are the effects on the invertebrates in the river. So we've basically had data back to 2014. We know in 2014 there were groundwater increases as well, and storm tank overflows were observed. And the Army score then at the site that's just below the treatment works did drop to below 9. And the evidence that we really see here, because the Army score is very, very variable, probably because of lots of other factors that are at play here. But the thing that does stick out is the blue-winged olive scores really do drop out when we have prolonged periods of storm tank overflows. And various people and papers suggest that this may be due to changes in phosphate concentration in the river system. I think this kind of site is an excellent site for starting extended Riverfly to look at the sensitivity. This is a site where this Army score is greater than, the trigger score is greater than, is 9 basically, so it's greater than 5. So I think this would be a really good kind of site to have a look at that new Army methodology to see what is happening in more detail here, because this is the traditional original Army Riverfly method here. Just one more example is the Smart Rivers observations. We started Smart Rivers and we started benchmarking this last year. We've benchmarked in May and in September. In May, groundwater levels were high. So there was quite a lot of dilution of the treated effluent from Chesham Sewage Treatment Works. In September, we had low flows in the river, so less dilution of treated effluent. We're also monitoring with the sensors. So we did our second Smart River sampling in September at the time when the treatment works had an ammonia treatment issue. So this is data from the sensors, and you can see the purple line is ammonium. So this is increasing. So at Chesham Sewage Treatment Works, at this current time, there was a problem with the treatment, which meant that ammonium wasn't being oxidized to nitrate. So high levels of ammonium were getting in the river system. And we were able to follow this, and we now understand exactly from this data when the Smart River sampling took place in relation to this problem. This is tryptophan, this purple line. The tryptophan didn't really increase at the time in the river system because it was really an ammonium treatment issue, whereas the organic matter total wasn't increasing massively in the river. So we were really interested to see the results of the Smart Rivers. So we have our spring samples, the blue here, the orange, which was done in the middle of this incident where the ammonium wasn't being treated fully. And you can see here that the actual riverfly diversity at these top sites in the river were quite low in autumn. So less than 14 is considered low for a chalk stream. So this is the site downstream of the sewage treatment works. This is actually upstream of the sewage treatment works in the urban area as well. So riverfly diversity at these two sites was pretty low in autumn 2022. And one last slide is with the smart rivers, you can get the SPEAR index, the chemical pressure. And again, this was the chemical pressure when it's low on the graph means that the chemical pressure is high. So the chemical pressure was high in the urban area and in downstream of the sewage treatment works here on the main chess. So that was really interesting for us. Unfortunately, we couldn't get at the phosphorus pressure because we had low diversity, and I think that causes issues for the phosphorus pressure score. So really interesting first data showing pressures from urban sources and effluent from the wastewater treatment works, but we need to start disentangling the effect of seasonality and treatment issues at the wastewater treatment works from this thing. So we're really looking forward to actually our next lot of sampling, which is in May, and then September, to try and sort of start to pull these data sets together. And as a final thing, we're also monitoring the emerging contaminants downstream at these same sites as well. So we should be able to soon, hopefully, pull all of that data together to start to tease out the different factors. So thank you very much. I want to really thank all of our really dedicated team of citizen scientists. We've trained up quite a lot in this last year for all of these new techniques. We've got a wonderful new citizen science coordinator, Hannah, who's really been taking this forward, and I wanted to thank her as well at this conference. And yeah, we're really looking forward to hopefully being able to show you guys all the data that's coming through these schemes in the coming years. Thank you.
Many thanks, Kate. Lots of reactions again as to Rick's talk as well, obviously having a big impact on everybody there. I can't see any specific questions after your presentations, so I've got one for you both probably. Amazing results on both initiatives, really high impact stuff. I guess the question I've got is, have you been able to achieve everything you set out to do? And if not, what are some of the blockers that you've encountered that have maybe limited your progress? That's a massive question, I know, but if you could give us a bit of a flavour for some of the other groups on here and how you've maybe got around some of those challenges.
Do you want me to
go, Rick? Please. Yeah. Do.
A couple of things in terms of Riverfly. It was that inability to, if you wanted to get a whole river sampled, it's having enough trained volunteers at the time. And looking at, I think it was the data, was it that John Davy-Bowker showed at the beginning? We did that in 2020, which looks like the time when there were fewest volunteers doing Riverfly, and the numbers are building up, and they're certainly building up again in our region. Because we have a chap called Tom Raper, who's now a tutor, and he's been doing lots of training locally. And so I think were we to do a kind of synoptic Riverfly, or to try to do the whole river using Riverfly, I think now we're getting close to the number of volunteers, in fact, who could do a kind of citizen science field excursion of that scale. So that would be a nice thing to be able to do Riverfly along a complete length. The other barrier has been just frustration working with the Yorkshire Water here.
For me, not really a barrier, but more the timing of things. So the Riverfly is really, really interesting, the tool, but I'd really like to be able to roll out extended Riverfly at some of those sites, because I think that's where the chess falls. You know, it's not a lot of the trigger values are not 5 or lower, they're higher. So we need those tools basically to start using those. That would be really good. And then it's the data. Sorry,
the cavalry's on its way.
It is exactly, and I'm really glad, and I'm being really heartened by hearing all of the efforts with this conference. It's great to hear that that's coming online and we can use those tools. The other thing is the data platforms, actually, for me, is bringing those all data sets from the different citizen science activities together, and in a way that not just a professional scientist can use, so that we can get help citizen scientists, all the ones that want to get involved all the way along the journey for interpreting the data and visualizing it as well. How can we do that? I think that's a really important question for us and a challenge.
I think that's the next big thing, isn't it? Great. So what I'm going to do is thank Kate and Rick for their excellent presentations now. Just to sum up very quickly before I hand back to Steve to close the conference, just some reflections from me on this afternoon's session, really. I think it's been three distinct phases for me. We've heard about how we're starting to place and develop citizen science on a more coordinated and strategic platform and focus. We've heard about the scientific complexities and challenges, but how that might present opportunities for citizen science to embrace moving forward, the emergence of new techniques and technology. And most importantly, we finished on demonstrating the power of the citizen science approach. And I, for one, have found that to be hugely inspiring. It's been great to really see the emergence of kind of, I don't know what you'd call it, but locally focused participatory research networks that are out there now, plugging the gaps in data and evidence, and how they're linking up with academic or regulatory science and sources of data. And I feel we are actually witnessing now a real revolution and a game-changing moment in how the citizen science plus approach is going to drive better and faster outcomes for our fresh waters. Today, I've been entertained, informed, and inspired, all rolled up into one, and I think that's a tremendous barometer of what I think has been not only a great afternoon but morning. And despite what the rail strikes have thrown at us, it's been a great afternoon session. I'd like to thank all the speakers and to hand back now to Steve Brooks, the co-chair of the Riverfly conference, to close. Thank you.
Thanks very much, Simon, for your excellent chairing of the afternoon session. And thanks especially to all of the speakers, both in the morning and the afternoon, for excellent talks, inspiring talks, and providing us with a very thought-provoking day. I'd also like to thank our audience as well. It's been fantastic participation from the audience. Can't help but thinking we've probably achieved better audience participation through an online meeting like this, with all the chat and everything, than we would have achieved had it been on, you know, face to face. I mean, we would have had the lunchtime interim for us all to get together and have a nice chat. But I quite like the audience interface that we've had through the Q&A session as well. So on that subject, I really appreciate getting some feedback from our audience about what they thought about having an online conference versus an in-person meeting, and perhaps a hybrid of that as well. As you all know, we've made a recording of the conference, and my understanding is that that will be made available at some time probably in the near future. And we'll also endeavour to answer any outstanding questions that appeared in the questions and answers in the chat. So basically, that just leaves me to finish the meeting. So thanks very much, all of you, for joining in. It's been a great day, actually. I'm looking forward to the next one already. Thanks very much.